Sir, this is a revision session, so how will it go? Like, will you explain the topics for the first 4 weeks first, and then take the questions, or you'll take the questions?
Yeah, like basically I'll take the question. Like if you have some doubt from any of the weeks, then I can start explaining all this.
Okay, sir.
Sir, can you explain the cardinality of basis ones?
Yeah, sir. What is the difference between a matrix and a vector is given when finding a basis?
Yeah, like they told you, please post your question. Like, just slightly
Okay.
write your question so that I can take I can follow some order. Like otherwise, it's not possible.
Okay, sir. Okay.
Sir, I think we should take the question later on, but the first we should revise. So basically, it's
No,
a
like
revision session.
revise in the sense like I cannot revise all the things in 2 hours, right?
Maybe like from the examination point of view, those topics which you think are important, like those topics you can explain in short.
Yes, sir.
Yes, sir.
Or maybe model questions also.
Session.
Or model questions.
We already
from
have
examination
open
point
session,
of
so I think we should start by
Sir, it will be very helpful.
Sir, can you
important topics in every week. That's it. You start from week 1, important topics.
Yes.
Then move on to week 2, important topics.
Sir, we used to solve the question in solve with us session and open session also.
Sir, can you explain how to find the domain dimension of the vector, sir?
Yeah, like sir, everyone is saying like we should better go with the topic and the related questions, because everyone has doubts in certain topics. So you can pick your own very important topics, especially in the vectors. So like we have very a few questions actually in the vectors. So you can start with the topic basics, and you can take some some exam level kind of questions. So that will be very helpful.
No, that is what,
Yes,
like,
week 3 and 4.
Okay, so let me tell you, like you have some mock paper, like so the question will be similar to the mock thing. Okay, so first you should start solving your mock paper, and you should ask then we'll take some another session. So after solving that mock paper, you can ask your question regarding the important thing. Yeah, Ajay, like we have already mentioned, all the things are actually important for your exam. Okay, so the thing is, if you have some specific doubt, then I can start explaining the concept also. Like I don't have problem explaining the concept, but if you have some doubt on some particular concept, then I can start explaining. Okay.
Sir, when will be the mock available?
So that's why I told you to put your question in the chat box so that I can take one by one. Yeah, that is.
Sir, is that mock is available on our dashboard?
No. Mock, like we will have one more session regarding regarding your doubt. So in that session, we'll take all the questions from mock. Yeah.
So if we'll explain the topics today, then we'll able to solve the questions really better way. Yeah, and like more importantly, week 3 and 4.
So the problem, as I said, like the problem is I cannot explain all the concept, like 4-week concept in a single session. Okay.
No, so we have most of the doubts from week 3 and 4, so you can focus on that today.
Yes, sir.
Yeah,
I agree.
All the doubts we will
yes,
3 and 4 only.
Yes, sir.
So better is like similarly in the week 3, so you can take topic and you can take the difficult questions, sir. Basics we all know, but we don't know how to solve the problems, especially in the mock test is comes and they are very different levels, sir.
So yes, sir, actually, basically, sir, problem solving tips and approaches.
Exactly, sir.
Sir, I think I have. Can I? Yeah.
So we need your perspective of solving the questions.
So I can understand the point. So what I think is probably if you take
see any specific problem if we take and then start discussing the concepts, that would be easier. I think general taking of topic will not be much helpful. I think that's what Sarah is saying. I tend to sort of align with that, because I've just pinged one particular question, sir. Any specific problem that you have come across which you didn't solve, if we take it from there, then I think that would be better rather than going topic by topic, because it's again, some topics may be clear to some may not be clear to
No,
others.
my
But if you
point
take a specific problem,
we're not saying to explain every topic. We're saying to explain those topics which are important from examination point of view. So
no, that is what I'm saying.
Week 4 is enough, I think.
Okay, so
yeah,
okay.
week
So
3 and 4. Week 3 and 4.
I have one
Okay, so let
week.
okay, please,
I think majority
okay,
can
listen to me. Okay, first of all, as I said, if you have some doubt, please post your question, even if it is some conceptual doubt, not related to some question. Please post your question in the chat box so that I can take one by one. As I said, it's not even for week 3 and 4 also. Like I cannot cover all the things whatever is there in week 3 and 4. Okay.
Sir,
So
can we raise hand and then tell a doubt? It would be
no,
easier.
then then it's difficult for me to know like who raised the hand first and who did after someone else. Like
Sir, at
then,
least you can cover the week 4 today.
Week was
Please.
rushed compared to the rest of the weeks. We prefer if you just focus on
Please
week
cover
4.
week 4.
So I think the majority we could go.
Yeah,
by that,
majority is for week 4. So please focus on that topic.
Sir, can you please tell the weightage for the quiz one of different
no,
weeks?
weightage is the question is similar. Like as you know, it's all the weeks are related to each other. So it's difficult for me to tell individual weightage of each weeks. Okay.
So, sir, can we expect like equal weightage from all the weeks?
Okay, like mostly you can say like, but yes, there's some difference can be also there. Like,
Okay, sir. Thank you, sir.
yeah.
Sir, one more thing, like I have done the practice assignments of week 4, and the concept that was explained, like I have seen the solution PDF, and the thing it was explained like there are some concepts from week 5 itself which are not taught in week 4. So things like nullity. So like
No, we will not ask any question from this from nullity. Like the syllabus is up to week 4, not
So please
because
acknowledge
week 4 solution contained like week 4 practice solution, if you see that contains like explanation contains those things like nullity plus rank, which are not taught to us actually. So I found it difficult to understand the solution of practice assignment 4.
Sir, the graded assignment solutions provided consist of nullity and they are not taught to us.
Sir, when will you provide mock test?
Yeah, maybe tomorrow or maybe day after tomorrow. Like I have
today is the mock test, right? The time mock test from 8 p.m. to 9 p.m.
Sir,
I got the email.
Acknowledge the fact that most of us are having doubts in week 4. So please cover the concepts of week 4 rather than going topic by topic.
Yes, I agree with you.
Yes, the majority is with this only.
So basically conceptual difference between subspaces and how we can like,
yeah, that is the problem.
We didn't
like,
get proper time for
okay,
revision.
so as someone said like some doubt in subspace, I was checking the chat box, most of them have doubts in week 3. So basically what you are saying, you have doubt in week 4, that's why you are saying most of the people have doubts in week 4. Okay, that is not the case. Okay, so that is what I'm saying. You please post your question in the chat box. You are simply wasting the time.
Sir, there is a doubt in graded assignment.
Okay, someone actually posted like he had some doubt in graded assignment question 4. Okay, while explaining the question at the same time, I will try to explain the concept also.
Okay, sir.
Yes, sir, it was my question.
Yeah, question number 10.
11, sir. Last question.
Okay, 11.
No, sir, 10 is mine.
Yeah, that is what I have checked. So, so can you tell me what is the question? Question number 10. So, because actual graded assignment question is slightly different for different people actually. So maybe, yeah, it's showing some
Week 4.
Yeah, week 4. So
I can give you one set of values. That's fine.
yeah, so suppose you have, it's given that you have a vector space. X, Y, Z, and the Z coordinate satisfy something. So what is that condition? Z coordinate satisfy this condition, 7x plus 7y is basically Z is equals to 7x plus 7. So this is my space. So as you can see, this is basically, it's a, so you can check that this is a vector space, vector subspace of R3 because it's a subset of R3, right?
Is it given, sir? Is it given?
Yeah, so basically it's given that B is a vector subspace of R3, right? It's given in the question.
Yes, sir.
So what you need to do?
Somebody is talking, sir. You can mute him.
Yeah, so so it's given that span of,
Voice is breaking.
am I audible?
Now it's okay, sir.
Yeah, so it's given that span of E 0 1 and span of 0 Q 1 is basically V. Then you need to find the value of 1 by PQ, right?
Yes, sir.
So
One question, sir. What is meant by span of these two vectors are V?
span is basically set of all linear combination of the elements so suppose you have a set S. So let me discuss what do you mean by span. So I'll come to this question. So before that, let me discuss what do you mean by span. So suppose you have a bunch of vectors, right? So suppose you have a bunch of vectors. So set up all linear combination. So span of S is basically set of all linear combination of elements of
TCP का वो ये है ना, इसमें नमक नहीं मिला हुआ है, थोड़ा सा मलाई चाहिए होगी हमको.
Please
और ये इडली का
mute.
पेस्ट,
Okay, so please mute.
इसमें से थोड़ा सा इतना पेस्ट यूज हो जाएगा, कल नहीं ना, तो निकाल के फ्रिज में रख दो, इसी में फिर इडली का भर के रख सकते हो, है ना? निकालते करते.
Yeah, okay, fine. So okay, so when you are unmuting yourself, please mute after that. Okay. So this is basically set of all linear combination of the elements of S. So basically if I can write some V as a linear combination of the element of VI's, that means
linear combinations.
is in span of S. So I have to consider all the elements B such that I can write this B as a linear combination of these elements of Vi. So if I can write this B as a linear combination of the elements of Vi, then this B is in span of S. So so basically I have to take all the elements, all possible elements that I can write as a linear combination of this VIs.
Can you
Right?
explain linear combinations, sir? That word, I'm new.
Okay.
Can you for a second, yeah, we can cover this while solving this. Can you? Oh, so once you finish this, can you go to that problem and solve that, sir? So things will become clear. Once you explain.
Can you explain me, sir, once more, please?
So okay. So sorry, Aman, what is your question?
Sir, can you explain this once again?
Which one?
This planning, sir.
Yeah,
Sir,
so that is what.
set.
So that is like what I am saying. Suppose you have a set. So
Sir,
the set.
Actually, sir, I could not understand.
No, so I'm repeating whatever I said. I'm repeating it again.
Yes,
so,
sir.
So you have
sir, please explain, sir.
So
sir,
you have bunch of vectors.
Once more.
Yeah, I'm doing. So
yes,
so you have bunch of vectors. So what do you mean by span of S? So span of S is basically set of all linear combination of the elements of this set S. You take all the possible linear combination. You take all the possible, whatever linear combination you can get from these n elements, you take all the elements. That set is basically span of S.
Sir, here AI means any value, any real number, sir.
Any real number. Okay, so
yes,
so suppose my set S is 1. So S is a subset of R. So then what will be the span of S? What will be the span of Hello? Am I audible?
Yes, sir. Yes, you're audible. Every real number would be the span of S.
All real numbers.
So basically you take set of all possible linear combination of 1. So that means you take A dot 1. So where A
is a real number.
A is a real number. So if I take any real number, if I take maybe 5, maybe pi, so pi is also in the span of S. Because why? Because I can write pi
3.14.
Pi into 1. So here A is pi, right? Because here my scalar is pi. So I can write pi as pi times 1. So if I similarly so that means since I can write pi as a linear combination of 1, that means pi is in span of S. Similarly, you take 100. If you take 100, I can write 100 times 1. So here A is 100. Okay, that means 100 is also in span of S. So in particularly, if you take any real number, which is in R, that means you can write R as R times 1. So R times 1 means you can write R as a linear combination of 1. That means R is in span of S. 1. Right? So that means span of S is basically span of S. So in this case, when S is 1, so span of S is basically R.
Real number.
It's basically all real numbers. Okay, so because I can write any real number as a linear combination of 1. So that's why span of S is R.
The span is only 1. Not
Sorry?
A into 1.
It is a set of vectors.
It's a set of all vectors, so such that you can write the elements of the vector.
I'm asking the span of that is only 1. That set is only 1, not A into 1.
Which one?
I'm asking that A into 1 you have written.
You're confusing the set with the span.
Because this is a linear combination of linear
Okay, that is
combination.
not the span. I mean, the one, only the set one is the span, right?
Why?
I mean, A1 is the span. Right?
No, why? What is the definition of span?
It's like scaling your one. If you scale one to any
See,
value,
what is the definition of span?
that's the span.
Span.
Yeah, that is understandable. I'm just asking, what is the span of, like, in this one, only the set one is the span, right?
No, no. What is my question? What do you mean by span?
Sir, using that we can attain the other numbers, like other.
No, you tell me precisely. Like the thing is, you span is basically all possible linear combination of the elements of that set.
Ah, yeah. Okay.
So I am taking all the linear combination of one, and I just show that you can write all the real numbers as a linear combination of one. So if I can write all the linear real numbers as a linear combination of one, that means my span of this set one is basically R, because I can write all the real numbers as a linear combination of one.
So can we say that one is span of one is real numbers?
Yeah, that is what I have written, right?
Okay, okay, sir.
All the numbers can be multiplied by 1.
Yeah, so basically, yeah, true.
Sir, can you go back to the question, sir? We have just not touched on it. Yes,
basically,
this one.
that we can use that number to get any vector, right? As a coefficient.
Yes. By using so basically the thing is a vector V is in span of S. So here S, suppose S is V1 to Vn. So a vector is actually is in span of S if you can write this vector as linear combination of all these Vi. If you can write this vector, as linear combination of all these Vi. Okay, so then you can say that V is in span of S. So you have to take all the vectors which you can write as a linear combination of this Vi. Then only
So
you can say that vector is in the span of this set S. Okay,
so multiplication is included here. No addition we can do in linear combinations.
Linear combination is basically it's a mixture of scalar multiplication as well as addition. Because
Yeah,
what is
sir.
this? What is this? A1, V1, A2, V2.
Okay, sir. Okay. We are doing multiplication and addition at the same time.
Yes. It's
Okay.
a mixture of two operations.
And the set of span S will
Okay,
be
sir.
linear independent, right?
So okay, let me tell you, let me give one more example. Like okay, I'm doing some easier examples, you can say. So so suppose my set is,
Excuse me, sir. What will be the basis for this question for the above question?
okay, so let me tell you one more time. Please mute yourself. Thing is, if once I'll remove you from the session, you cannot join it again. Okay, so whoever is talking, I'll simply from the next time I'll simply remove you from the session. This is the
Sir, please
first and
remove
last
them.
one. Whenever you are not talking, please mute yourself. Okay, so I'm muting all of you. So the next time whenever you are talking, you unmute yourself, and when you finish your question, please mute yourself. Okay. Otherwise, don't blame me. Okay, I'll simply remove you from the session. So okay, so I just want to know.
Excuse me, sir.
Yeah.
What will be the basis for the above question?
Which one?
That A into 1.
Yeah, I'll come to that. Okay, let me discuss about span. Okay, then so after that, then I can talk about linear dependence, independence, and basis. Okay, so better I should spend some more time on span. Then I will go to this basis and all this. Okay. So my question is, what will be the span of this set? So this is a set which consists of two elements. So I want to know what is span of.
This will be R2.
R2. Span of
Span of
R2.
So
Span
why?
of R2.
Why the
Because I can achieve because I can achieve any vector in the R2 by the linear combination of these two vectors or a scalar multiplication of this vector.
True. So this set is basically V1 and V2. So if I take any element of R2, okay, so I'm taking an arbitrary element of R2. So to show that span of S is basically R2, what I need to show? I need to show that if I pick any arbitrary element of R2, then I can write this element as a linear combination of the elements of S, right? So if I take X comma Y, then X comma Y is basically Y into 0, 1 plus X into 1, 0. So as you can see, this is my V1, this is my V2, and this Y is my A1, and this X is my A2, right? So in particularly, if I take some particular element, let's say 10 and 7, so then I can write 10, 7 as 10 into 0, 1.
One question, sir.
Sorry.
7 into 0, 1.
7 into 0, 1. 10 into.
One question, sir. Can I ask?
Just a minute. 1, 0.
Sir, again.
Amitabh, when you are not speaking, just mute yourself. Amitabh Bhattacharya. When you are not speaking.
Oh, I am sorry. It is purely mistake from my side. No intent, not intentional.
Okay.
Yep. Sorry.
So as you can see, I can write 10, 7 as a linear combination of 0, 1 and 1, 0. So this is, so here I have taken a particular example, particular element which is a element of R2. So as just now I showed, so there is nothing special about 10 and 7. I can take any arbitrary element of R2 and I can write that element as a linear combination. You take some element, maybe some 119. You just replace the value of Y here and you replace the value of X here. You can write that element as linear combination of 0, 1 and 1, 0. Okay, so that means I can write all the elements of R2 as linear combination of 1, 0, 1 and 1, 0. Let me complete it. So that means, so what basically I proved that span of 0, 1 and 1, 0 is basically R2. Yeah, so this is, yeah.
Can you please take an example of a set which is not, span of which is not R2?
Yeah, I'll take that. Yes.
Sir, same here, sir. In the same example, sir. So when we say like 10, 7, actually they are nothing but a span of 0, 1 and 1, 0, the fundamental vector, sir. So what do we call 10, 7, sir? This is a linear combination of this 0, 1, 1, 0. Okay.
True.
Sometimes the question comes over, okay, 10, the 10, 7 spans 0, 1 and 1, 0. That time actually I get confused. Okay.
No. 10, when you are saying no. So you are saying 0, 1, 1, 0 spans 10, 7, right?
Yes.
No, this is not a right word. When you are saying that 0, 7, 0, 1 and 1, 0 spans 10, 7. So basically so that statement basically it means span of this is 10, 7, which is not correct, right? So whenever you are saying 0, 1, 1, 0 spans 10, 7, you are basically saying span of 0, 1 and 1, 0 is basically 10, 7, which is incorrect, right? So when you are writing 10, 7 as a linear combination of 0, 1 and 1, 0, you should say that I can write 10, 7 as a linear combination of 0, 1 and 1, 0. So when actually you are saying that 0, 1 and 1, 0 spans 10, 7, basically So spans means you are taking all the possible linear combination. You are taking this set. Okay, this is a set. You are taking this set. When you are saying 0, 1 and 1, 0 span something. So span of this is basically R2, right? So I can say that 0, 1 and 1, 0 spans R2, not 10, 7. Am I clear?
Yes, sir. Correct.
Yeah. So you can say that you can write 10, 7 as a linear combination of 0, 1 and 1, 0. And similarly, you can, so basically you can say that you can write any element of R2 as a linear combination of 0, 1 and 1, 0. That is
correct.
So we can say that 10, 7 is in the span, right?
Spanning set
Sorry.
So we can say that 10, 7 is in the span, right?
Yes, true. You can say that 10, 7 is in the span of this. In the span of this is also correct. Yeah.
And spanning set, sir?
Sir,
the
for
spanning
example,
set
if we take whether
of
10
R2.
and 7 is spanning 0, 1 and 1, 0, that is fine?
No, so 10, 7 is in the spanning set of 0, 1 and 1, 0.
Yeah, true. You can say that 10, 7. So when you are saying 10, 7 is basically, you can say that 10, 7 belongs to span of S. That is correct. Okay.
Sir, I have a doubt.
10, 7.
Sorry?
So can we append 0, 1 and 1, 0 by 10, 7?
Why you want to append it? I just want to compute the span of this set.
Actually,
append, then what
let
will
me
happen?
tell
No,
you.
then you are going to basis and all these things, linearly dependence, independence, all these things. But I simply want to know the span of this set. Okay. I simply want to know span of this set, and this is what I am doing. So one thing you can say that, yeah, 10, 7 is basically, you can write 10, 7 as a linear combination of 0, 1 and 1, 0. So that's why 10, 7 is basically in the span of S. Okay. And basically I showed that span of this set is basically R square. So if the span of this set is R square, then I can say that this set spans R square. Okay, but why you want to append 10, 7 in that set? Because I simply don't want to compute the span of some other set. I simply want to compute the span of 0, 1, 1, 0 and 10, 7. Yeah.
So actually they got confused. Okay.
Appending hello.
See, again I'm saying, okay, just allow someone to talk. Like, don't try to interfere in between.
Sir, can I ask a doubt, sir?
That's why.
Sir?
Yeah.
I'll say an example. Can you just write it? Let S is equal to set ordered pair 2, 4, ordered pair 3, 2, 1 and ordered pair 1 minus 1. Let this be a subset of R2. Can I say that a linear combination of A into 4, 2 plus B into 2, 3 plus C into minus 1, 1? Will this element be the in the spanning set?
Yeah,
A
that
into
is
4, 2 plus B into 2, 3 plus C into minus 1, 1.
Yeah, that is the definition of span, right?
No, it's not A into 2, 4. It's A into 4, 2.
A into 4, 2
plus B into 2, 3
B
plus
into
C into minus 1, 1.
Minus 1? 1.
Can this element be in the spanning set of?
Okay, in this case, actually, I guess it will be in the spanning set of S, because I can see that because the span of,
because A spans the entire R2, so it will always be
so
spanning.
here the span of S is basically R2. Okay, so that's why you can say that this is actually in span of S. Okay, but this is not true in general. You cannot switch the coordinates.
Sir, this is just a column transformation, right?
Sorry?
This is just a column transformation, right? If I take a matrix 2, 4, 3, 2,
no,
1
for example, if you are taking, suppose say 0, 1, okay, so you cannot say that 1, 0 is in span of S, right?
But aren't we doing just a column transformation? In that case,
my question is whether I have a simple question for you. If S is 0, 1, okay, can I say that 1, 0 is span of S?
No.
So simply then you cannot apply this concept everywhere, right?
Okay, got it.
Why can't we say that?
That is
Explain.
only if it is a complete vector space we can do it.
So
Yes,
so
because
it's
y will
not like
always
you
come
can
zero, that's why you cannot
flip the coordinates every time. Okay, in this case you can do it because the span of S is basically R square. So it doesn't matter whether you are flipping the coordinates, you are changing the coordinates, you are putting some other coordinates. It really doesn't matter because the span of S is basically R square. So instead of 4, 2, if you write something else also, you will get so that will be in the span of maybe some 7, 3 also, that will be in the span of S, because here span is basically whole space. So if you take some linear combination, you cannot go beyond of that space. Okay, so it really doesn't matter what you are writing here, but
one point.
the point is you cannot
Can we
flip
consider
the
revision session like
coordinates.
revision rather than interruptions, please, for everyone? Let's take it as a revision session, and if you have the doubts, let's put it in the comment box and raise hand whenever side finds the time. Then you will entertain. Otherwise, follow the flow of revision.
Sir, please,
Sir,
sir,
I have a
explain.
doubt, sir.
Sir, actually the main
Sir,
question is
please,
remaining.
explain, sir.
Sir, I
Sir,
have a doubt,
doubts.
sir.
Sir, doubts, please take afterwards, sir. Please
Sir, I have a
explain
doubt,
first.
sir.
So what I'm doing right now, like I'm explaining a concept, right?
Yes, sir. You have finished explaining, sir. Can you go to
Sir,
the
other
question, sir, which
people
you
are
started
talking
off?
too much.
Please finish your thing, sir. Please, sir.
First I started with a question, then after
Yes,
that
sir.
I came to explaining some concept. Now
Sir, we did not
I'm
take up the
explaining a
question at all,
concept,
sir.
and in between you are asking your doubt. Okay, so
Yes.
then shall I mute all of you and start explaining by myself? Like I should not take then any questions.
Yes, sir. Please mute everyone.
Yes, sir. Go that way.
So
That would
can
be
you
much
go to the
better.
question, sir? As you said,
Yes, sir, it's
you can go to
best.
the question, sir, which we
Sir,
started off.
mute everyone and just go with your flow.
Sir, you have started off
I
with the
think that
question.
will
Can you
not
go
be
back to,
good.
sir? Can you go back to the
So
question,
yeah,
sir?
so
Which we started off.
so okay, so whoever asked this question, so yeah, so basically, so my main point is you cannot flip the coordinates. Okay, so in general you cannot flip the coordinates as I showed in this example. If S is 0, 1, and if you flip the coordinates, then actually this doesn't belongs to span of S. Okay, so that is not true in general, but for this particular question, it turns out to be yes, you can do it because the span of S is basically R square. Okay, so
Sir,
Hmm.
sir, in this
Sir,
set
can you go back to the
0,
PQ
1,
question, sir?
you say that if we flip, there will be no difference here, but basis will be get different.
Sorry?
Sir, you say that S is equal to 0, 1. If we flip to 1, 0, then span will not change. Okay, but when we talk
No,
about
what I'm
basis,
saying, if I flip the coordinate,
in this case, basis will change.
No, don't talk about basis now. What I'm saying that whether you agree that 1, 0 doesn't belongs to span of S.
Yes, sir. Yes, sir.
Then we are done, right? We cannot flip the coordinates.
Yes, sir. Yes, sir. We can go back to the
So
question.
this is a singleton set. So this is the basis of this set, the span of S. So this basically it's a linear independent set. So this is basically a basis of span of. Okay, I'll come to that. Okay, so yeah.
Sir, span of S 0, 1 is R, right?
No, it's not R actually. It's basically it's your Y axis.
Yeah, we cannot say that it belongs to R.
No, how you so S is first of all S is not a subset of R. S is a subset. S is a subset of R
She means
square.
dimension, sir. She means dimension, sir. So R2 or R1 like that, sir.
Yeah, that is okay. So if you are saying dimension, yeah, maybe you can say the dimension of the span of S is 1, but certainly span of S is not R. It's basically X axis, Y axis. So what is span of S? A into
It's a y-axis.
So basically what? This is basically 0, comma a, where a is in now. So this is basically y-axis. We're taking all the points. So basically you can write all the points on the y-axis as a linear combination of 0, 1. Okay. So so whether the span concept is clear now, like how actually we are getting the span of some particular set.
Yes, sir.
Okay.
Sir, is there any singleton set which spans the whole R2?
It's not possible actually. So why it's not possible? Okay. Can one of you tell me why a singleton set cannot span whole R square?
Singleton set can expand only in one direction.
I think
Or one axis.
Yes, sir. One should be.
Singleton set itself is not a vector space.
So because it is, if it is like even if we take 1, 1, if we scalar multiply it by anything, it will not be negative. So negative numbers will get skipped. So similar conditions can get skipped.
No. Actually, whatever you are saying, like okay. So the thing is,
can I tell?
Suppose you are taking
Singleton sets and only move in a line.
Yeah,
and for
true.
R
Then-
square, we have to
Yeah,
cover
this
a
is
whole
a
plane.
correct argument. If you take a singleton set, if you take a point, so if you take a point x comma y, then span of x comma y is basically a line which passes through origin and x comma y. Okay, so basically you cannot get whole plane out of this x comma y. Okay,
Okay.
so hardly you can get a line. Okay, if it is not 0, if it is the vector is itself 0, then basically you will not get anything. It's basically 0, 0. Okay.
Okay, sir. Thanks.
Hello, sir.
So if you take 0, 0, then the basically span of S is basically S. Okay, you will not get anything. So one way to show it, like if you try to show it, that algebraically you can say that if X is so suppose this is your point, so this is your set S, then you can show that you cannot write 1, 0 as a linear combination of xy and 0, 1 as a linear combination of xy simultaneously. Okay, this you can show. Okay, you cannot do it simultaneously. You cannot, if you have a singleton vector x comma y in R square, then you cannot write this 1, 0 as a linear combination of x comma y and 0, 1 as a linear combination of xy simultaneously. Okay.
Hello, sir.
I think alphas betas will be on the left hand, right? Like alpha 1, 0 equals to xy, right?
No, you want to compute the span of S. I want to show that the span of S cannot be R square.
Got it.
So what basically I want to show that I cannot write 1, 0 and 0, 1 as a linear combination of xy simultaneously. Okay.
Hello, sir. So I have a question. Suppose in R3 we have two linearly independent vector.
Now I'm talking about span.
Sir, I have question also in spans.
Yeah. So if you have some question in span, then ask me.
Yes, sir. Is span and linearly independent both?
No, now I'm going to, because see, I want to solve this question.
Related, sir. So
basically I want to solve this question. Okay, so that's why I started explaining the concept of span.
Sir, can you solve the question right away now, sir?
Sir, I think same question, sir.
So that is what I'm saying. What is your question?
Please scroll up. The vector there PQ I have seen now. So in R3, it is given that two linearly independent vector. So scroll up, please.
This question you are talking about?
Yes, sir. Yes, sir. So it is given that two linearly independent vector PQ. Whatever.
No, it's not given in the question. Like,
sir, my question is related to. Sir, I am saying that two vectors is there, right, sir? Suppose two vectors are linearly independent of R3. So how will get the another linearly independent vector and which is span the whole set, whole subspace, vector space? So you get my questions?
No, but the problem is you are not getting my point. Okay, the problem is you are.
Okay, so I'm waiting. Sir.
So this is.
Sir, I have a question related to span. So you say that one is a span of R. Now, any real number is a span of R except 0. Is my statement correct?
Yeah, any if you take any real number A in R, which is non-zero, then span of A
so
is
only
basically
only 0 is not span of R.
Not 0. Span of 0 cannot be R.
Okay. R. Yes. Span of 0 cannot be R.
0 cannot be R. Okay.
Sir, why, sir? 0 comes under real number. I mean, span of 0.
Can you explain me that, sir? Why 0?
Span of 0 is basically 0.
Sure.
Because
It
multiplying
can't be
with
expressed
any
in
number
any
with 0
linear
we get 0.
combination.
Sorry?
So it can't be expressed with any linear combination. So that's why it is not a span.
If you multiply 0 with a scalar, eventually you will get 0. Okay, you cannot get anything except 0. So that's why span of 0 is basically 0. Okay. So so it's given that this set. So it's given that span of this set is 0 P01 0 Q1 is basically V, right? So I want to find out the values of P and Q. Now, if I pick a arbitrary element of my vector subspace P, so if I take some arbitrary element,
ask something.
Yes.
Sir, here is span of two set P01 and 0Q1 equal to V. It is given. Sir, that means it is a basis.
It turns out to be a basis. Yeah, true. Yeah.
So, sir,
So we can't assume, sir. We yet to prove. Cannot,
you need
unless
to
and
prove
until
it. You can prove
assume.
that this is a basis. True.
But
You
that
need
will
to
come
prove
later,
it.
sir. So that will come later, sir. We are jumping to that.
True. Yeah. So, so as I can, as from the condition, I can replace Z with something else, right? Because there is a relation between Z and X, comma Y. Okay. So what I will do, if I will pick an element of Z of my vector space B, okay, it should be in this form, right? It should be in this form, 7x plus 7y, right? So this is the arbitrary element of B, right? So now what I want to do, I can write this xy 7x plus 7y as x 0 7x, right, plus 0 y 7y, right? So so that means, so basically what I want such type of elements where so one element where the Z coordinate is, so in each of these elements, as you can see, Z coordinate is 1. So when I'm trying to write a element of this as a linear combination of two other elements, so I have to convert these elements so that the Z coordinate of these elements is basically 1. Okay, so how I can convert this? If I can take 7 out of this expression, then the Z coordinate will be basically is X. Then I can take X common from that coordinate. Okay, so let me tell basically what I want to say. So what I can do, I can make 7x out of this expression. Okay. So basically, this is 1 by 7, right? 0, 1. This is 7y, 0, 1 by 7, 1, right? So this is fine, right? So this step is fine.
Can you explain?
Yes, sir.
Step that is
Sorry?
x. Can you explain me this step that is x, 0, 7x? How did you get that? How come you split 7x plus 7y in such a way? It's a normal matrix addition, sir.
This is just vector addition. It's a vector in R3. Like I'm just adding two vectors. Like as you can see the whole point is so you want to span, like you have to make this x you have to put this x in one place and you have to put y in another place. So that is what I am doing. I am splitting this x and y.
Okay, sir.
Yeah. So okay,
so if I may just come in over here to the question that was asked by the candidate, I think there was a tutorial help that was there in week 4, wherein it said how it should be split. So if one has to split it, it can be split in multiple ways.
True.
This is not the one necessary, but there is a standard algorithmic way that was suggested. See, x comma y, 7x plus 7y, how many independent variables are there? There are only 2 independent variables. So when we split it, we have to keep one independent variable as 1 and the all remaining independent variables as 0. And we keep following that in an algorithmic way, we will get the standard splits.
Yes.
That is what is being done here.
Yeah,
I think that is what people it took a lot of time for me as an individual to understand how we are splitting. Splitting is this algorithmic way it got split. X was kept as 1, y was kept as 0. That's how we got the first component. And plus next step we did x as 0 and y equal to 1. Then it came out. That's how it is.
Explain us, please.
So as you can see, so basically what I'm doing, so as you can see, I can write any element of B. So what basically I am doing, I can write any element of B as a linear combination of this and this, right? That is what I have done here, right? I just showed that if I pick a arbitrary element of my vector subspace B, then I can write that element as a linear combination of 1 by 7, 0, 1 and 0, 1 by 7, 1, right? So basically what I showed that span of seven 0, 1 by 7, 1 is basically B, right? So now can you get the value of P and Q from this set, because P is 7 and Q is basically 7.
Yes, sir.
Yeah. So then so basically, yeah.
Can I suggest you something like, sir, can they at least send the steps, I mean, in non-graded assignment and graded assignment, the answers, right? At least can you just send the steps with answers with proper steps, like it'll because almost everyone who are waiting for doubt session, we are having doubts in the not graded assignment and graded assignment. If you guys send the proper steps, we won't have a problem in it. At least we can just concentrate on the people who are having doubt sessions. Right.
So you want the solutions of activity question, right?
Yes, activity graded as well as not graded.
Sorry?
You can give graded as well as not graded. We have
we are providing you the solutions of practice assignment and graded assignment, right?
So the activity also important, sir. Now
No, activity
is
then what basically you will do? Like if we'll give you all the solution, then basically what you will do?
No, sir. See, sir, out of 10 questions there, I'm getting eight questions properly, and 2 questions I'm facing difficulties. And I'm coming here for asking those out, but we are, if people are asking doubts in this.
No, that's if we are giving you solution, then basically you are not doing anything. If you simply go and check the solution, then you will not learn anything. You are not getting my
Sir,
point.
we are actually trying. After trying out, we don't know where, like how to solve. So we will check it that time.
The solution
sir, then they can post in discourse forum, no?
The solution can be posted after 1 week or 10 days. Right?
Yeah, same as after deadline of this thing. No, like you can if you do that, it will be very helpful. Like we will save a lot of time for you guys. I'm telling, and we can just concentrate on teaching.
No, I don't think it's a good idea.
No, sir. So what
So
he's trying to
can I
say?
ask a question? Like we are short of time today.
Okay, so this part is done, right? The span of this set is basically V. Okay, so from here you can get this basically this 1 by P and Q is 49. Okay, so from here
P is 1 by 7, Q is 1 by 7.
Yeah, P is 1 by 7, Q is 1 by 7. So then 1 by P by Q is 49, right?
Yes. Sir.
Yeah.
So can I ask my doubt? It's not related to this.
Okay, so
I basically had a doubt between what's the difference between a subspace and a dimension. Sorry, basis. Subspace
Krishna
and
Mohan.
basis.
Krishna Mohan, are you here?
Sorry, sir. Yes, sir.
Yeah, so you have asked some questions, sir. Please explain n plus 1 and the above set of vectors in a vector space are always linearly independent.
Yes, sir. Yes, sir.
So the thing is, you want to know like why. So suppose
because the lecture it's given that we have an Rn space, vector space. So vectors will take minimum of n plus 1 and beyond. Like n plus 1 vector will automatically always be linearly dependent. It cannot be independent. So I wanted to know that it's conceptually okay, but how to actually prove it or take an example, concrete example.
Okay, so suppose you have bunch of vectors and you want to know. Suppose you have so suppose you have n plus 1 vectors. No, like you want to know the proof or what? Like my question.
Yes, sir. I mean, like in sense, how is it that let's say we have R3 or even R2, but we are taking V1, V2, V3, V1, V2, V3, so it will always be linearly independent.
Yeah. So basically, what is the issue? Yeah. Okay. So what is the thing?
I thought it was actually independent. It could be. That's what I was thinking.
No. Suppose you have the 3 vectors in R2, right? And you want to know whether this set is linearly independent or not. So basically what you need to do, you need to find the solution of this thing, right? You need to solve this system.
So as per the lecture, what they're saying is, since the vectors here taken are more than the
basically that is the reason. That is the reason. Okay. So basically what you will get. So you will get a system of homogeneous equation, right? So basically what you will get. You will get A plus
2B plus 3C equal to 0.
3C equals to 0. And
2A plus 3B.
2A plus 3B
plus 4C equal to 0.
4C equals to 0. Right?
So we have number of unknowns more than number of equations, right? Yes, sir. So if the number of unknowns are more than number of equations, obviously there will be independent variables, right?
There will be independent variable. That means you have a non-zero solution, right?
I mean, independent variables will be there, but I thought independent variables will be there, so this also will be independent. But actually, it's they're saying that.
So what?
Yeah.
So okay. So the thing is, if the system. So independent variables means one of the variable can take any value, right?
Any value, yes, sir. Yes, sir.
So suppose you have some value of A, right? You have some value of B, and so suppose C is the independent variable. Okay.
Yes, sir. Okay.
So suppose C is non-zero, right? C is
Yes.
suppose say 5.
Yes.
Right.
Okay.
So that means A times 1 2, B times 2 3, 5 times 3 4 is 0, right?
Yes.
So that means this set is linearly dependent, right? Because you
okay.
can make this linear combination to be 0 where one of the scalar is non-zero.
Non-zero. Okay.
So the thing is, see, the whole point. Okay, so you have to understand that solving okay, to know whether set is basically linearly independent and dependent is basically equivalent to solving a system of linear
equations. Yes.
If you know how to solve a system of linear equation, then basically you know whether a set is linearly independent or dependent. That's all.
Okay.
So
got it, sir. Because if you have unknowns more, then obviously at least one unknown will be non-zero. Which will be and since it is part of the vector space here, that is equating to 0 0. So now obviously then one of the coefficients will definitely be non-zero, and that's why they'll be linearly dependent, right?
True.
Okay.
Sir, from where you got that 5, sir?
No, I'm simply taking some value. Okay, it's not like I'm just taking some value. Okay, I see. I have not solved this system. I'm just, since you have a system of linear equation where the number of variable is more than number of equation, then you will have an independent variable, right? You have some independent variables. Suppose the independent variable is C, then that means C can take any value. So in particular, I'm taking C to be 5. Okay, so my whole point is point was to show that I can make this linear combination to be 0, and such that one of the scalar associated to that linear combination is non-zero. Then basically I can say that this set is linearly dependent. Okay, that is the main point. Okay, since this system has infinitely many solutions, because you have a independent variable. Okay, so if suppose C is independent variable, then I can take any number for C. Okay, so in particular, if I take C to be 5, then I can get this equality. And in this equality, as you can see, this is non-zero.
So on that note, how can we say that if determinant is 0, then it is linearly independent?
That is if you have n vectors in Rn, then you can apply that algorithm.
So how can we say that it is linearly independent?
Sorry.
So then how can we say that it is linearly independent if determinant is 0?
You cannot apply determinant trick here.
No, sir, not here. But if we have n cross n matrix, then.
So if determinant is 0, then that system is linearly, that set is linearly dependent. Dependent if determinant is 0. If determinant of non-zero, then that set is linearly independent.
How can we say that, sir? Why? How?
Oh, you want me to prove that fact?
Yeah, sir.
Okay, it's fine. I can. Then obviously again it will take time. Okay.
Sir, I'm sorry to interrupt for a second. Can you please show me the above slide? I just want to take a snapshot.
This one, right?
No, sir, that's C1.
Yeah, quick.
Where you show the value of C, like C is equal to 5. That.
Can you mute?
Which one?
Where shall you show the value of C is equal to 5?
Okay, like okay. I just simply okay. You can. I will. I'll show you some. Like you better you go and check the record. No, sorry. So. So suppose you have a matrix, right? Suppose you have a let's say 2 cross 2 matrix. So I have say two vectors AB and CD, and say determinant of A is non-zero, right?
Yes, sir.
So so I want to show that this A comma B and C comma D is basically linearly independent, right? So basically what I have to show, I have to show that A comma B, alpha times A comma B plus beta times C comma D is 0 if and only if alpha comma beta is 0, right?
Yes, sir. So this will conclude that it is linearly independent.
Right? So so you know, like if the system is so the matrix is invertible, then this matrix has only one solution, right?
Yes, sir.
X is 0 if and only X is 0, right?
Right, sir.
So if I multiply this matrix with X comma and X1 and X2, then basically what I will get?
0.
No, X1 A comma B, right?
Yeah.
X2 C comma D.
Right.
Right. So when this will give me 0.
When X1 and X2 is 0.
If and only if, that is the only possible case where you can make this linear combination to be 0, right? Because this X1 and X2 is basically the solution of this matrix, right? And the only solution of this matrix is basically 0, 0. That means this linear combination can be 0 if and only.
That means if we are saying determinant is 0, we are equating that linear equation to 0, right?
Yeah. So the whole point is, if the determinant is 0, then you have a non-zero solution, right?
Yeah.
So if the determinant of is non-zero, then you have only one solution. Okay, that is 0, 0.
In that case, it will be linearly dependent.
No, if determinant is non-zero, then in that case that is linearly independent.
Sir, when we have infinite solution.
So can you say those words of determinant and 0 again? The condition again?
Okay, there is one thing you guys can do. Those who have doubts in week 3, week 4 session, you can go to YouTube and see the session. They have explained clearly, like 2 hours. They have explained everything. And just saying, it's a possible idea. No, you guys can go and see those videos, or you can, if you have some more doubts, you can go to our dashboard and see the videos from first. Just say.
I want to say it is explained by Susmita ma'am clearly.
Sir, if it is determinant is 0, then it will have unique solution, and that means it have a linear combination, right?
Okay, so if determinant is 0, then you will have infinitely many solutions.
I have two doubts in this. Can I ask now? So that is just you have written, right? X1 AB plus X2 CD equals to 0. So that means X1 A plus CX2 equals to 0, right?
Sorry.
So X1 AB plus X2 CD you have written equals to 0, 0 matrix, right? So that is AX1 plus CX2 equals to 0. And BX1 plus DX2 equals to 0, correct? Okay, so
that is see, this is just a linear combination of A, B, and CD, right?
Yeah.
So instead of row, I am just writing in terms of column. Okay.
Yeah, sir. Got it.
Yeah. So this linear combination is 0 if and only if the scalar associated to this linear combination.
Okay, so my second question is, what is with the trace value? And the linear dependent and independent relation.
Sorry, trace value.
Yeah, trace of the matrix.
No, I guess there is, as far as I know, I guess there is no relation in between linearly dependency and independency with the trace.
Okay.
As
Sir,
far
may
as
I ask
I
a
know, I
question
guess
now?
there is no relation with the trace of the matrix and with the linearly and linear dependence and
Like the diagonal of the matrix, sum of the diagonals.
that is the trace, right?
Yeah, that is that is trace.
No, as far as
Sir,
I
in the
know,
case of
like there
determinant,
is no relation.
sir, in the case of determinant equal not equal to 0, there will be linearly independent, and you may have unique solution or non-zero solution.
If determinant of 0, that means you have infinitely many solutions.
It's not equal to 0, then it's linearly independent, and you are having unique or non-zero solutions.
Yeah. Determinant of 0, then this is basically infinitely many solutions.
When we have unique solution.
If determinant of non-zero, like as far as I know, we have covered all these things maybe some 3-4 times at least in the session.
Unique solution.
Sir, I have a question. May I ask?
Yeah.
Hello.
Sir, will that unique solution be the trivial solution?
See, trivial solution is always a solution. If you have unique solution, that means that is the only solution. Okay. So because you have a homogeneous system, right? So in the homogeneous system, 0 is always a solution. And when I'm saying this homogeneous system has a unique solution, that means 0. I already know 0 is always a solution. And after that, I'm saying this system has a unique solution. That means 0 is the one and only solution of that system. See, that is what I am.
So can we conclude that if the determinant is not 0, the unique solution will be the trivial solution? Can we conclude like that?
Yes.
Yeah, that is
Sir,
what
am I
said,
audible?
right?
Sir?
Yes.
Sir, I have a doubt from graded assignment 4, week 4. May I ask?
Certainly, I'm following one order. Let me go through that order. Yeah. Sandeepan.
So the example you have given here.
Question 11, sir.
Yeah. So what, like some example what I gave?
So yeah, here if x1 and x2 is equal, if x1 and x2 equal to 0, it will be linearly what?
No, here I was trying to show that. So if the determinant of the matrix is non-zero, then this is the only solution for this system, right? For this system, A into x1 and x2 equal to 0, 0. This is the only solution to this system, right? So,
Yes, sir.
So the solution of the system is equivalent to this fact.
Okay, so thank you.
If I have a solution x1 and x2, then actually using this x1 and x2, I can make this linear combination to be 0. If I have only one solution, that is 0, 0, then this is the only, so this is the only linear combination through which I can make this linear combination to be 0. That means this set is linearly independent. If I have non-zero solution, that is the case when determinant is 0. If I have a non-zero solution, that means one of the xi is non-zero. Suppose x1 is non-zero, then here x1 is non-zero. I don't care about x2, and as you can see, this linear combination is 0, and where x1 is non-zero. That means this system, this set is linearly dependent.
Yes, sir. Okay.
Yeah. So question number 11. Suppose V is a vector space
Sir, I think before that I have posted my doubts, sir. There was like to explain the rank and dimension.
Okay, sorry.
My name is Harkishan. So yeah.
Yeah.
Like it was right after Krishna Mohan.
Sorry. Yeah. Sorry. Explaining rank and dimension of what?
Sorry, sir.
Rank and dimension of what?
Sir, just the basic concept, sir. I get confused between like
Yeah, that is
rank
fine.
and dimension.
That is fine. But I want to know, you want to know the rank of matrix or
sir, vectors.
Okay, vector space. Okay.
Yes.
So basically, okay. So it's so basically in more or less the correct word is basically I suppose this is dimension. So in one sense, actually rank more or less correspond to a matrix, and dimension correspond to a vector space.
Vector space.
Okay, like this lecture actually I guess are used even rank for dimension also. Like when I'm saying basically rank of a vector space is basically dimension of a vector space. They are basically same thing in case of vector space. Okay, and there is nothing called dimension of a matrix. Okay, there is nothing called
rank of a matrix is there.
There is nothing called dimension of a matrix. This is there is nothing called dimension of a matrix. You can either talk about
so rank is for matrix and dimension is for vector space.
Yes,
like that.
True. And in actually in lecture actually sir also used the word rank of a vector space. So when I'm saying that rank of a vector space, that basically is same as dimension of a vector space.
So sir, is it always this is the case?
Yeah, it's
rank is equal to the dimension.
No, the meaning is basically same. So rank is basically dimension. Okay, he just simply used some different word. Okay, so basically they are same. Rank and dimension of a vector space. These two words are basically same. When I'm saying that rank of a vector space is basically dimension of a vector space, I'm talking about dimension of a vector space, nothing else. Okay.
Understood, sir. Thank you so much.
So okay, so what is your question? Like regarding...
Sir, can you explain like taking an example of vector space, like how to find its dimension?
Sir, for example, 11 number question of week 4. So in that question, the dimension for 3 into 3 cross matrix, if the diagonal sum is 0.
Yes. So basically, I guess someone asked me that question. Okay, I'll come to that. Just before that, let me discuss something about this rank and dimension. Okay, I'll come to that question. Basically, you are asking maybe question number 11, or maybe whatever you are asking is basically related to question number 11. Okay.
Yes,
because I'll explain that question. So, but I just want to know, so can one of you tell me some example where I can discuss the dimension of that vector space? Don't give me matrix space, that I will come, but I simply want to do it for Rn or maybe something else.
So for example, consider a set B, A, B, comma, C, where A plus B equals to C and A, comma, B plus, comma, C belongs to R. So in this, we have to find the dimension.
A plus B, A, comma, B, comma, C, and what is the relation?
A plus B equals to C.
A plus B equals to C, right? Okay. So
considering the usual addition and
yeah, true. So so the thing is, okay, so before that let me define what is dimension. Okay, so so suppose you have a vector space. So what is the dimension of that vector space? It's basically the cardinality of a basis. Okay, so So what the first thing what you need to do, you have to find a basis of the vector space. Okay. And how you will find the basis of a vector space? For that, you have to find a set S. Set S, so that this set is linearly
independent.
And the second thing is span of this set S should be V, right?
Yes, sir.
So you need to find a set S so that you can write all the elements of B as a linear combination of the elements of the set S, and as well as the set is linearly independent. So the cardinality of that set S is basically dimension of B. Okay. So for example, what is the dimension of R?
It will have one basis, so 1.
So yeah, so give me an example of a basis of R.
1.
Yeah, this is a basis of R. See, already we have proved that span of B is R, right? That I guess we have proved it in the very beginning, that span of B is R. So yes, so as I mentioned here, you have to show these two things, that the span is the whole space, and another thing is that set is linearly independent. So it's clear that this B is linearly independent because
singleton,
and that is non-zero. So alpha times 1 is 0 if and only if alpha is 0. So that means you can make the linear combination to be 0 when the scalar itself is 0. You have no other possibility. Okay. So that means this set is, the span of the set is R, and as well as this set is linearly independent. That means B is a basis of R. Okay. So that means the cardinality of B is basically 1. So the dimension of R is 1, right? So similarly, I'll come to this question. So similarly, what is the dimension of R square?
1 0 0 1 2.
I'm talking about dimension of R square. It's 2. So how I can show that the dimension of R square is 2? For that, I have to provide a basis, right?
Yes, sir.
So what will be a basis of R square?
1 0 0 1.
1 0
1 0 0
0. So we have already proved that the span of
is R2.
R2. So the next thing what we have to prove that B is a basis. To prove that B is a basis, we have to show that span of B is R square and B is linearly
independent.
So how I can show B is linearly independent? So I have to prove that this linear combination, 0 1 0 0, just a minute.
Hello. Hello.
Hello.
Sir,
yes,
you
sir.
are not audible.
Yeah, I told you.
You are not audible.
Sir, if the cardinality of basis and cardinality, let's say, of a spanning set will take, will that also be the same?
Sorry, can you repeat?
cardinality of a basis is equal to the dimension of that vector space, right? Now, let's say apart from this basis, if we take cardinality of a spanning set, that will any arbitrary spanning sets cardinality be the same as the basis cardinality?
No, that is not the case. Okay, so also you need some another condition that set should be a linearly independent set. So okay, I'll come to that. Just let me complete this one. So I want to show that this set is linearly independent. So for that, what I have to show? I have to show that this linear combination is 0 if and only
alpha beta 0.
Which is obvious, right? Because this linear combination is basically alpha comma beta. So this linear combination can be 0 if and only if alpha comma beta is basically 0. So this set is linearly independent. So that means the dimension of R2 is 2. So as someone said, so instead of this, if I'll remove the linearly independency condition, so then I can take this set instead of this 1 0. I simply add one more point. 3. So this is my, say, B dash. Okay. So here span of B dash is R2, because since span of B, so span of B is R2, that means span of B dash is also R2, right?
Yes.
But I cannot take the cardinality of this set as the dimension of the space, because then this will become 3. Okay, you will get some different value. Okay, you need the linearly independence condition. This, as you can see this set is not linearly independent.
Yes, sir.
Yeah. So because why? You can write 3 as linear combination of 1 0 and 0 1. So this set is not linearly independent. That is the problem. If you take any set, any spanning set, that won't give you the dimension of the vector space. You have to take a spanning set, as well as that set has to be a linearly independent set. Okay, then the cardinality of that set will give you the dimension of the vector space.
In lecture, it was described as the minimal spanning set. Maybe.
Yeah. So basically, yeah. So that is basically the minimal spanning set. It's basically equivalent to the fact that that basis. If it is a basis, then basically it's a minimal spanning set. Yeah.
Yes.
Sir, the book recommended in this course, so I've gone through that book. So this 1001, so they call it standard basis. The book called them the standard basis.
Even we call it as a standard basis.
Okay. So there can be other bases apart from those.
Yeah, true.
Okay.
Is maybe if you remove this point, maybe say remove this point. This is also a basis, right?
Yes, sir.
So this is also a basis of R2. So you basically you have infinitely many bases for Rn. Okay, but
the dimension will be unique. Dimension will be same for
But in the lecture, they mentioned that multiple bases is an advanced concept and not covered actually. So that's one I think, because
if I put
trying to find out the basis, more than one basis of a vector space is a complicated thing, I guess. That's what the lecture was saying, that we'll stick to having only one basis.
No, I guess that is not the case, because in many questions we gave some different basis other than standard basis. So okay, so the next question is this:
these two vectors, like suppose you mentioned in matrix form, the dimension will be same, just 0 1 and 2 3. If you want to represent in a matrix form, like 0 1 2 3, so the dimension will remain same dimension. There will be 3 dimensions, right? If I put.
Sorry, if you put.
So suppose is two vectors.
Yes.
Zero, one,
yeah.
And 2, 3. If you want to represent in a vector form,
they are in vector form, right?
Yeah. No, sorry, in matrix form. Matrix form. So 0, 1, 2, 3. So what will be the dimension of it? Like if you want to represent that,
no, this rank of this matrix
is also 2.
Rank of this matrix will give you the dimension of span of.
Okay. So I think this is my question was related to the 11 number question that was earlier asking.
But how are we solving the 11 number question actually? We didn't solve it yet, na?
So manually
I will solve it. I will solve it. Yeah. Okay. So okay. Let me first try to solve this question. So this is my space, right? Say some condition is there, a plus b equal to c. C, right? So this is a subspace of R3, and I want to know the dimension of this subspace. I want to know dimension of V. So to know the dimension of V, what I have to do, I have to find out a basis, right? Of V. So now you pick a, so for that I have to, so for that the basis should satisfy this condition, like the span of that B should be V, right? So so if you pick a arbitrary element of V, then it should be in this form, right? A B
yeah,
B, right? So the same idea. First I will try to split A and B. Okay. So this is my A, this is 0, this is A. This is 0, B, right? So this is A times 1, 0, 1, B times 0, 1, 1, right? So basically what I have done here. So basically what I have done.
identify the basis.
Not basis. Basically what I showed
You
here.
define the vectors as a linear combination of A and B to
So
coefficients.
basically what I showed here, I can write all the elements of the vector space V as a linear combination of 1, 0, 1 and 0,
1, 1,
1, right? Yes. So I can write all the elements of the vector space as a linear combination of 1, 0, 1, 0, 1, 0, 1, 1. That means span of this set 1, 0, 1, 0, 1 is V, right?
Yes, sir.
In this 101 and 011, we are only getting numbers that are we cannot get 001, can we?
Sorry?
No, we can't get, because that will fail the condition provided here. A, B, A plus B.
Got it, sir. Got it.
0, maybe whatever you are saying, it's not an element of the vector space. Okay. So the span of this.
And will it be a vector space? It won't be a vector space, right?
Which one?
0, 0. If 0, 0, 0 isn't present, then will
0,
it be
0?
As 0, 0, 0 won't be present.
Why?
It will be present.
It's there.
0, 0, 0 will be present.
0, B equal to 0 equal to C.
Because 0, 0, 0 satisfy this condition, right?
Yeah, but if you look at the matrix, right? If you just scroll down a bit.
Sorry?
Just scroll down a bit. Scroll down. Yes, sir. This way. A little bit more, sir. Scroll. Sir, bottom
The
of the
solution answer, yeah.
yeah, sir. This when you said A 101 and B 011, this won't give me a 000 matrix, right?
Why? Why? If you take A to be 0 and B to be 0,
to be
what
0.
will you get?
Okay, okay. Yes, sir, got it, sir.
Yeah. So basically what I showed, the span of this, as you can see, I can write a arbitrary element of B as a linear combination of 1, 0, 1, 0, 1, 1. So that means span of this set is B. So to show that, this is a basis of the vector space B, what I have to show? I have to show that this is
Independent.
This is linearly independent because I have already showed that the span of this B is basically B. So to show that this is a basis, I have to show that this set is a linearly independent set. So which is again more or less easy, because if I take a linear combination, and as you can see, this can be 0 if and only if
A and B 0.
This is 0. That means both A and B has to be 0. Otherwise, you cannot make this linear combination to 0. Okay. So this linear combination is 0 if and only if A and B are 0. That means this set is a linearly independent set. So the span of B is B and B is a linearly independent set. So it satisfies all the condition of basis. That means B is a
basis.
B is a basis of.
Cardinality 2, so
dimension
rank
is
would be
2.
2.
Yeah. Clear, right?
Yes, sir. Yes, sir.
So
yes.
So I have a doubt. So suppose matrix A is of the form 3 and 2, 4. Can you just write that down? A is of the form 3 and 2, 4. No, dimension 3 and 2, 4. Elements are not necessary, sir.
Okay, it's a 3, 4 man.
Yes, sir. So we studied that the rank of row vectors of A is equal to the rank of column vectors of A. Is it the same that the rank of A transpose?
There is nothing called rank of row vector, rank of column vector.
So in the lectures, sir was saying,
so okay, sorry. Rank means dimension. Yeah, dimension of the column space.
Column
Dimension
vectors of yes, sir.
Yeah, that is space, column space, and dimension of the row space. Yeah.
Yes, sir. Can you write that down too? So is that also equal to the rank of A transpose, like the row vector?
Yeah. Rank of A is basically rank of A transpose.
So even if the dimensions of the matrix is 3 into 4 and 4 into 3, that doesn't matter, right?
Sorry? No, that doesn't matter. Yeah, true.
Okay.
No, this even if it is not a square matrix, that is also true. Like the rank of A is same as rank of A.
So then also, how are we solving the question actually?
Sorry?
How for 4x4 it is coming 9?
Question number 11 you are talking, right?
Yes.
Yeah, I'll come to that. Right. Still in the queue. Okay. Okay, so this part is clear.
Yes, sir.
So okay, so now you can find out the dimension of a vector space, right? If some condition is given, then so basically all you need to do, you need to find out a basis. That's all. Okay. Okay.
Thank you, sir. Thank you very much.
Thanks. Okay, so question number let's come back to question number 11. Okay, so B is a vector space. It's basically 3 cross 3 matrix. E consists of 3 cross 3 matrix. So So with some conditions that A is a upper triangular matrix and the sum of the diagonal entries of the matrix is 0, right? So A is upper triangular and sum of the
it's 4 by 4.
It's maybe it's for you, it's 4 by 4. Yeah. But the idea is basically same. There is nothing new. Like you can follow the same procedure.
So 3 by 3 is solved in tutorial. Please solve your 4 by 4.
No, why then if that is the case, then if you have understood properly for 3 by 3 case, then you should able to solve 4 by 4 also.
No,
I don't
sir,
see
the
I don't see any difference. No,
is in
I
the
don't.
diagonal
Sorry,
elements.
I don't see any difference between 3 by 3 and 4 by 4. Even
Yes,
if I am doing for 2 by 2 case also, if you can understand you can understand it properly, then you should able to solve it for 3 by 3 case also. There is no difference between 3 by 3, 4 by 4. It's the same idea. The only thing I have to write bunch of more some more elements. Okay, the idea is same.
4 cross 4, the diagonal condition will be different. 3
Yes,
cross
sir, that is my concern. Diagonal elements differ in 4 by 4.
Whether one
please go ahead with the 3 cross 3, sir.
Yes, sir. Yes, sir. Please go ahead with the 3 cross 3.
How many is independent, dependent?
It's not independent dependent. You see, when I'm talking about the dimension of a vector space, the one thing you should do, you should find out the basis. Okay, so first you have to find out the basis of that vector space. ABC. So this is the upper triangular matrix, right? So this is 0, right?
Yes, sir.
ABC D E. This is
0,
0,
0, F.
This is F. So this is my space, right? And with some extra condition that sum of the diagonal is 0. That means A plus
D plus F equal to 0.
Is 0. So this relation is given, right?
Correct.
This is given. So this is my vector space. This, okay, this is, you can say this is a subspace of this.
Correct.
Right? So, so I want to find the dimension of V. So for that, what I have to find? I have to find a basis of this vector space, right?
Yeah.
So again, I have to use this relation. So if I pick an arbitrary element of this vector space, it should be in this form, right? It should be in this form. A, B, C. See, from here, I can write F as minus A, minus T, right?
Yes, sir.
So I'll just replace this over here. 0, D, E, 0, 0, minus A, minus T. So an arbitrary element of B should be in this form, right? Should be in this form. This is an arbitrary element of B. So, so as you can see, I can write this as A into 1, 0, 0, 0, 0, 0, 0, 0, minus 1, right? As you can see, I'm splitting this A, B, C, D, E, F. That's all. This is A, this is minus. Again, 0, B, 0, 0, 0, 0, 0, 0, 0. 0 0 C 0 0 0 0 0 0. The next thing is 0 0 0 0 1 0 D 0 0 0 minus T. And then last one is 0 0 0 0 0 1 sorry, not 1, this is E 0 0 0, right?
Yes.
I can write this matrix as the sum of these 5 matrix, right?
Yes, sir.
So
Okay.
Please.
So, sir, this is my point, sir. So generally, if we suppose this is a matrix 3 cos 3. Okay. So if you go by the dimension rank, so a 3 cos 3 matrix cannot have a rank more than 3.
Yeah.
Yes, sir. But when we are going for the dimension, we're getting 5 dimension.
No, the problem. Okay, so again, I guess, yeah. So again, you are confused with 2 different things. Okay. So the thing is, rank, when you are talking about rank of a matrix, okay, so that is basically you need to find out. So when I'm talking about rank of a particular matrix, so when I'm talking about rank of a particular matrix, this is a vector space. Okay, so when I cannot, so here you don't have a particular matrix, right? You have infinitely many matrices, right? You don't have a particular matrix. So this B doesn't contain a single matrix, right?
Okay.
This space contain infinitely many matrices, right?
So that means, sir, that to finding rank, like for row echelon form, reduced row echelon form, is for only for coefficient matrix, right, sir?
No, so okay, so I'll come to this. Okay, so just give me some time. I'll come to this question. So before that, let me tell you something. So I guess you are confused with two different things. Okay.
Sir, also on that note, I would like to add this question to the bucket. That is, when we write the basis vectors, like if you just go back to the previous page once, can you just, yeah. So when we write this matrix as basis vectors, either we can go like A0 0 B D 0 C E minus A minus D, or we can do like A B C 0 D E 0 0 minus A minus D. The way you have broken actually each every row and every element in every row, right? Like you can take the 5th matrix and the 4th matrix, 0 D 0 and also 0 0 E. We don't have to take it like that, right? We can do 0 D also, right? That will still be a basis vector of mine.
No, like I didn't get your point. Like I'll come to that.
Okay, sir.
So the thing is, when you are computing some rank, so the rank of a matrix, some n cross n matrix. So this will give you the dimension of the column space of A, which is same as the dimension of the row space right. So when I'm taking a matrix 1 2 3 4, the rank of this matrix basically will give me dimension of span of 1, 2.
Okay. Yes.
3, 4, and basically which is same as dimension of the column vector, span of the column vectors, right? So I have a specific matrix here. Okay, so for that specific matrix, I can talk about rank and rank of that matrix. So basically, when you have bunch of vectors, so basically what you do when you have bunch of vectors in maybe say R3, what you do, you put the vectors in a matrix form, right? So you put them in a matrix form, right? So suppose you have A, B, C and X, Y, Z and some E, F, G. You have 3 vectors in R3. So what you do, you try to put them in some matrix form.
Then it's column wise, no such. That's what
it doesn't matter
redshift.
basically.
Doesn't matter.
Yeah, because the rank of A and rank of A transpose are basically.
But we could put it as column wise also, no? Sir?
Yeah, no issue.
Okay.
No issue. So first, what you do, you try to compute the rank of this matrix. Okay, so the rank of this matrix will basically give you the dimension of span of this set. Okay, so the rank of this matrix will give you the dimension of span of this set.
Okay,
but you cannot do the same trick when, so when you have matrices like this, 1, 2, 3, 4.
So you mean to say if there's a dependent row in the original matrix, like in R3, then my span will decrease by 1 degree? Because my rank will decrease by 1. No?
You know how to compute the rank, right?
Yeah.
So whatever you will get, that will give you the span of this set. That's all.
For this matrix, my rank can be 2, right?
Which one?
For A, B, C, X, Y, Z, E, F, G, the matrix you have taken.
It can be 1, it can be 0, it can be 3, it can be anything, right?
But my span of this matrix will stay in 3, right? R3.
Yeah, the span of this matrix.
Span of this vector matrix, A, B, C, X, Y, Z, E, F, G.
No, I'm not talking about span of this matrix. I'm talking about rank of this matrix.
Yeah, but you have equated them, no? Rank of A equals to.
No, I am saying the rank of this matrix
equals to dimension of span of this.
Span of this set S. This set S.
Yeah.
This set S. This rank of this matrix is same as span of the set S. Dimension of the span of this.
So in this case, if
in
ABC XYZ case,
there is no specific value of A, B, C, D, E, F, G. So I cannot talk about anything. They can be anything. So they can the rank of the this can be.
Rank can be 1, right?
This can be 0, 0, 0, 0, 0.
Yeah, correct.
0. In that case, rank is 0. Okay. This can be 1, 0, 0, 0, 1, 0, 0, 0, 1. In that case, rank is 3. Okay. If my vectors are this 0, 0, 0, 0, 1. So the rank of matrix is 3. And as you can see, span of this set is basically dimension of the span of this set is R3. So that dimension is basically 3.
Okay, sir. Got it.
So in that, if this is 0, 0, 0, this can be 0, 0. In that case, the rank of the matrix is 2. And the span of this set is dimension of the span of this set is 2. Okay.
Got it.
So here I have not specified any values of this A, B, C, D, all these things. Okay. So the thing is okay. So when you have vectors in R3, you can apply the same trick. Okay. When you have vectors in Rn, in Rn, you can write these vectors in a matrix form, and you can compute the dimension of that space, span of that space S, by computing the rank of that matrix. But you cannot apply the same logic here. Suppose this is my set S. And I want to know the span of S.
Okay.
So so you are basically what you are trying to
okay
say?
okay, so that means we cannot go for the same process like
Yeah, so what basically you are trying to do, you are just taking a matrix from that from this set,
okay,
and you are computing the rank of the matrix.
That's
Okay.
not,
That is not correct. See, the rank of this matrix, as I said, the rank of this matrix will give you the dimension of this set, span of 1, 3, 2, 4. Okay, not the span of this set. Okay, when you are computing the rank of this matrix, it will give you the dimension of this one. Okay, not the dimension of this one, right? Is it clear what actually I'm trying to say?
yes sir, yes sir. But I understand that.
Sir,
Like,
That means we have to calculate separately for both the matrices.
So you have to
So-
look at from the vector space angle, not like simply matrix.
So, sir,
So
you
the
meant to
thing is,
say-
okay, so the thing is, there is a trick you can do, but it's really difficult. What I can do now, I can think this matrix as an element of R4.
okay, yes.
So how I'll see it? 1, 2, 3,
4. Yes.
4. Now I can think this as an element of R4. So I have to, so that is what I'm saying. I'm taking 1, 2, 3, 4, and this I'm taking, you have to follow the same order.
Okay,
right?
okay.
So first I'm taking 1, then I'm taking 2, then I'm taking 3, then I'm taking 4.
then
Similarly, I will
3,
follow
5,
the
6,
same order. 3, 4,
5, 6.
5, 6. Now what basically you have done, you have converted this matrix into some element of Rn, right? Now this is an element of R4. Now this is an element of R. Now you compute the rank of this matrix, this new matrix, 1, 2, 3, 4, 3, 4, 5, 6. This rank of this matrix, rank of this matrix will give you the dimension of this set S.
Okay. So
this set S.
Okay, that meant to say, sir, that the question on 11 number question, that was a vector that can be in number of arbitrary number. Okay.
Yes.
That is not a coefficient matrix like
exactly.
The A.
So yeah. So the thing is, what basically you are trying to say, you are trying to say that rank of a 3 cross 3 matrix cannot be more than 3, right? But
yes.
the problem is when you are taking a particular matrix A, B, C, D, E, F, G, H, I. So you have to understand that the rank of this matrix will basically give you the dimension of what? Dimension of span of this set. A, B, C, D, E, F, G, S, I. Okay. So this will give you the dimension of this space. So if my vector space is this V, then dimension of V is basically rank of this matrix. Okay, but here as you can see, the V is completely different.
Okay, because there is a theory, sir, like there's a concept that if it's a 3 cross 3 matrix, the maximum dimension can be 9, like n into m, right, sir?
Yeah, no, not 3 cross 3 matrix. It's basically a vector space. It's consists of all 3 cross 3 matrices. Okay, there is no specific matrix. See here, when I'm writing like this, I'm asking what is the dimension of this vector space. I'm not specifying any matrix, right? I'm not specifying any matrix. It consists of infinitely many matrices. It's a vector space.
Okay. All are real number. A, B,
obviously, it's a real matrix.
No, that is right. Like you can be n number of arbitrary number. We put arbitrary number, you can get this kind of dimension. Okay, I got it.
Yeah. So the thing is, okay. So you have some difference when you are talking about a rank of a matrix. It's basically giving you the dimension of the column space and as well as the dimension of the row space. Okay. So, but in this case, as I said, in this case, if you pick some particular matrix, if you simply choose a matrix from this vector space, it will give you the dimension of that particular matrix. It won't give you the dimension of the vector space. To find out the dimension of the vector space, you have to find out a basis basically. Yeah, that is what I am doing here. I'm trying to find out the basis of this vector space.
Okay.
So can you scroll down a bit? So here and bottom. No, up. So where you said the span of V, scroll up, please. Up. Up. Scroll up. So I don't know where is it written. So you said the span of V, the dimension of span of V, that statement where you have written.
Where?
Dimension of span of V.
Dimension of span of V.
Yeah.
No, I guess I have not written anywhere. Dimension, yeah,
So,
basically I have written dimension of span of S. Okay.
So that in that case, the span should also be linearly independent, no?
Sorry?
To find the spanning set should also be linearly independent, right?
Yeah,
to
that is what
find
I'm going to prove.
rank.
Basically,
Yeah.
what I showed here, I showed here that so first I'm trying to find first basically I'm trying to find a spanning set for this vector space. Okay. First I'm trying to show that I'm trying to find a spanning set of this vector space, and then I'll show that spanning set is basically a basis. Okay.
Sir, I have it another way. Sir, just scroll down, sir. There's a you mentioned one. There's just a little bit, just more. Yes, that's S 1 2 2 1. That set 1 2 3 4. That set that spanning set. So can I write the first one is the first set of matrix that you have written?
This
that
one.
is a 1 3 and 2 3 vector. We have a 1 2 and 2 3 vector. And
sorry,
second one
I still I didn't get anything. Like this is my. You are talking about this question or something?
Yes, yes, this question. This
is so this this set contains matrices, right?
Yes.
So one of the matrices 1 2 3 4. Another one is 3 4 5, and I want to compute span of this dimension of the span of S.
Yes, sir. Yes, sir.
So basically,
So I just want to know if one, not going into spanning part, I just want to know if I want to draw these particular matrices, two matrices into vector form. So can I write 1 2 3 4,
yeah,
1 2 1 vector and 3 4 another vector?
Sorry,
that's 1 2. This is a vector 1 2. Suppose x is a x column is the first column, y is the second column.
that actually that you cannot do, because you are splitting that vector. You have to make it into a single vector. Okay, when you are writing 1 2 3 4, then basically you are making into two different vectors. So you are splitting this. So this is a single vector. Okay, this is a single vector. So as you can see, I have converted this matrix into a single vector 1 2 3 4. I've converted this vector into a single vector 3 4
No,
5
sir,
6.
he's talking about the spanning set you have written in the right side. Spanning set 1 3 and 2 4.
No,
So
no.
can we write?
I'm talking about the
this one.
These two matrices are mentioned in this S.
No, so you are saying that whether I can write this as 1 2 3 4, right?
Exactly.
No, you can't do that, because the problem is you are splitting one vector into two different vectors. That actually, as I said, if you are writing, you can write. Suppose if you have a matrix.
But this representation is not seen in the lectures, or like writing it like a ravel, like 1 2 3 4 as a column vector or column matrix.
No, that is basically that is not necessary. I am using something which is actually is not In more or less, I'm using some isomorphism.
Yes, sir. It's not
Yeah.
material. That's why
So
it's confusing.
so no. The thing is, why actually I wanted to tell you. See, to know the span of this. Okay, to know the span of this, you can convert this into a matrix form. Okay, you can compute the rank of the matrix, and this will give you the dimension of this. This one, but you cannot use the same trick over here when the set is 1 2 3 4 and 3 4 5 is two matrix, and you want to compute the span of the set S. You simply cannot pick a matrix over here, and if you compute the rank of that matrix, it won't give you the dimension of this space, dimension of this span of S. Okay, if you want to do it, you have to do it in this way. Okay, that is what my point.
So in this case, sir, what if this is in form of 3 into 3?
Sorry?
In 3 into 3 form.
Then that is the difficult part. Like you will get a big matrix, 9
long form, very long size.
Yeah, it's not easy. It's not easy. So
one more thing is when you are looking at this matrices,
okay,
you are looking from the point of view of vector space. So that's how we are tuning our mind to look at this span and the basis and rank. So here, when you took the second example to the left, we would want to look at from the vector space, how we represent this in a vector space. In that line of thinking, we are approaching this. So this writing 1, 2, 3, 4 as a single column is slightly confusing. That's why. If you scroll down. Because from vector space to understand rank and dimension and the span is easier than matrix from approaching from matrix side. That's what I was thinking, right? Here. Yeah, there's 1, 2, 3, 4 and 3, 4, 5, 6. So these two matrices, but how to look at this as a vector space? I just wanted to know.
No, I'm not taking a vector space. I'm taking just the span of these two vectors. So that's the span of a set is a vector space, right?
Yes, sir.
So I'm just taking the span of this set S, okay, which is basically a vector space. It's basically all the possible linear combination of these two elements. I'm trying to compute the dimension of that space, that span of S. Okay.
Is there any way the S here that you are defined, the 2 by 2 set of 2 by 2 matrices, two elements, to look from the vector space angle or something?
That is a vector space. See, the problem, okay, the main problem is what you are trying to mix. So you are basically trying to mix two concepts. Okay. So as I have already mentioned this thing. So basically when you are trying to find out this dimension of span of a set in Rn, you can put all the vectors in a matrix form, okay, and you can compute the dimension of the rank of that matrix, and it will give you the dimension of this span of S.
So we can put the spanning set into row space also and column space also. That doesn't matter, right?
Not a issue, because
sir, if the matrix is given 1, 2, 3, 4, then we can say that 1, 2, and 3, 4 is the spanning set of that matrix.
Sorry.
Sir, if the matrix is given 1, 2, and
no, now I'm talking about vectors in Rn.
Yes, okay. So here, just to recap, so here we have the vector in Rn. So we are translating into a matrix. So for the matrix, we calculate the how to come to the dimension of span S from the matrix.
So rank of this matrix will give you the span.
Okay. Rank of the matrix.
So the span that you mentioned, that is that is a 2 cross 2 matrix. That is a resultant of a one matrix. I can if for a particular point that is a resultant, we can find a resultant of a matrix through that.
What do you mean by resultant of a matrix?
Resultant means suppose 1, 2 in a x-axis. Just correct me, sir, if I'm wrong. There is a point 1, 2 on x-axis. Can you go back that back page, sir? Yeah. Okay, there's a one there's a one vector is 1 and 2 point. Another vector is 3 and 4 point. Okay, the resultant vector we can find over here from here.
So that is what I am saying. You are using one word resultant, but I don't know the meaning of that word.
Okay, so maybe okay. So I'm not a math background, I'm physics background, so then we call it resultant.
Yeah, then sorry. Actually, I don't know what you mean by resultant of.
Okay, whatever. So my term, pardon my terminology. So this is defining one point, and another matrix is defining another point, right, sir?
This is so you are from this matrix you are taking one vector 1, 2.
Yes.
And you are taking another vector 3, 4.
Yes. This is defining one vector on a xy plane, and another one defining another vector on another plane. Okay, and this is
vector.
And from that we get a resultant vector. I think that will be your.
Sir, he using vector of this.
Resultant matter means you are taking the addition or what?
Yes, addition, sir. Addition.
Addition. Okay, addition. It will give you some different vector. It's basically it will give you 4, 6.
Yes.
Yeah. So, but this has nothing to do with this thing, right? Like we are computing the rank of the matrix. That's all.
Okay.
One question, sir. So the column vector you have written here 1, 2, 3, 4.
Okay, let me complete this question first.
Sir, can I ask a new question?
So the thing is, this is my space, and I can write a arbitrary element of this vector space as a linear combination of these 5 matrices. Right? So this is basically A times some vector. I will name it V. Okay, as you can see, V is basically what? 1 0 0 0 0 1 0 sorry
0 0 0
0 0 0 0 minus 1, right? If I take A out of this matrix, then I will get this matrix, right? Similarly, I will get B into something 0 1 0 0 0 0 0 0 0 and C times 0 0 1 0 0 0 0 0 0 plus D times 0 0 0 0 1 0 0 0 minus plus E times 0 0 0 0 0 1 0 0 E, right? This is my V1, this is my V2, this is my V3, this is my V4, this is my V5. So one thing is clear, that span of, so basically what I have done here, basically what I have done here, I choose an arbitrary element of the vector space B, and I showed that I can write that element of the arbitrary element as a linear combination of these 5 vectors, right? I can write any element of the vector space B as a linear combination of these 5 vectors. So that means span of V1 to V5 is basically B, right? Span of these 5 vectors is basically B. So to show that this set is a basis of this vector space, what I have to show? So I already showed that this span of this set is V.
Question again, sir.
Linearly independent.
What is the question?
Linearly independent. So to prove that S is a basis of this vector space B, I have to show 2 things, that span of S is B and span of S is a linearly independent. I already showed that span of S is basically B. So all I have to show that this S is a linearly independent set. So it's more or less clear, right? Why? So can one of you tell me why this set is a linearly independent set? This
Because 0, 0, 0 matrix will be
A,
formed
B,
like
C, D,
A,
E,
B.
all 0.
Yeah, so basically this linear
Which
combination. So if I take this linear combination, this is basically, it's a 0 matrix. This linear combination is 0 matrix if and only if all these scalars, they are 0. So this linear combination can be 0 if all the scalars are 0. So that's why this set is a linearly independent set, and the span of this set is basically the whole space. So that means this is a basis of V, and dimension of V is 5, right? Is it clear, like how we are computing the dimension of this vector space?
Yes, sir.
Yeah.
So, but here, like when you split the matrix, is that the only way? Like similar questions, is that the only way? Because
this
it's like more of trial and error kind of thing.
Yeah. So basically, the thing is you need to find a basis. Okay. So I guess this is more or less a easy way, because when you are splitting all the variables, okay. So basically, when splitting all the variables, as you can see, a lot of entries of all these matrix are 0, right?
Yes, sir.
So once lot of entries of the matrix is bunch of matrix are 0, then it will be easier for you to check the span as well as linearly dependency and independency.
Yes.
Okay. That obviously that will be easy. That will be easier, right? When you have lot of 0 in your matrix, then it will be easier for you to compute the linearly dependency and independency, right? So that is the idea. Okay, so basically if you take, so basically what I have done here,
This is the one way that is
the same thing, whatever I have done here, so here I tried to separate A and B, right? So here I have two variables, and I've tried to separate A and B. That is what I am doing here. I have some, maybe say 5 variables. So I tried to separate all the 5 variables. Okay. So in first place I have A, in the second I have B, in the third I have C, D, and then E, right? So so using that I got a basis, and once I have a basis, then easily I can tell the dimension of that vector space. Okay.
This is only applicable when V is a vector space, right? If V is not a vector space, we can't find bases and dimensions, right?
Yeah. So see, the dimension is defined through basis.
Yeah. Okay.
So if you don't have basis, then certainly you cannot talk about the dimension. First, you have to show that the dimension of a vector space is n. Then you have to produce a basis whose cardinality is basically n. Okay, then only you can say that the dimension is basically of the vector space is n.
Yeah.
So can I ask a new question?
So this is the only way to get the basis. The dimensions, right? This splitting of the matrix, that's the only way, right?
Sorry.
The splitting of the matrix is the fastest or the only way to arrive at the dimension of a matrix. Dimension of vector space, right?
Yeah. So the thing is the splitting is basically, it's a easier way to find out a basis.
Okay.
So one extended question for this question.
So
if it was a 4x4 matrix, then the diagonal elements, could you brief it out how it would take the diagonal elements? So because the doubt is, if we have like, for example, the diagonal elements is A, B, C, D, then yeah, please write it down. Sir, so can we write it like A, B, and minus A, minus B, or we have to write it A, B, C, and the D is equal to minus A minus B minus
So you
C.
have this relation, right?
Yeah.
So how? So then how you can? So what is your suggestion? What you want to write?
Sir, either A, B minus A minus B,
A
or
B
A, B minus A minus B.
minus B.
Yeah. Or A, B, C.
Suppose my matrix is in this form. Okay. So when you are writing this, you are excluding lot of matrices.
So the condition is sum of diagonals is equal to 0.
0, but the thing is, when you are writing this, you are excluding this matrix. 1, 2, 3, 5, 6. Right?
Okay, sir.
You are when you are writing this, you are excluding all these matrices, right? So it's from here. So from here you cannot say that. See, this certainly this will satisfy this condition. Okay, but these are not all the possible solution for this equation. Okay. So as I mentioned here, this 1, 2, 3
What's
minus
a good
6.
way to write this?
This is basically it's better to split. So you better to write. You make one variable one side and other variable in your right side. It's better to write in this way, minus B minus.
Okay, so that will include the condition A, B
Actually
minus
that basically that will include all the matrices. Okay. All
Okay,
the
sir.
matrices. Okay.
Okay.
Because see,
Thank
these two conditions are equivalent, right? These two conditions, they are basically equivalent. A plus B plus C, D equals to 0 is same as D equals to minus A minus B minus C. But these two conditions are not equivalent. Okay. They are not
Okay, so
equivalent.
Can we count some number of independent variables?
So that is what I have explained. Like here, what do you mean by independent variable and dependent variable? It's a vector space. If you have a particular matrix, then you can talk about number of independent thing and dependent thing. When you have a vector space, how you will compute the
Sir, in that way we can see the condition. Based on that, we can identify the number of free. We can say free variables where we can assign the values to those independently, and some will be the based on the conditions. Some 2-3 variables may be the dependent.
No, you are saying this way or some.
Yes, sir. Yes, sir. In this way only, like you have written the first. So last minus A minus D is dependent. So directly we can count like 5 numbers of A, B, C, D, E.
Yeah. Yes. Similarly, here you will have similar kind of thing. Like mostly what you will have. So 3, 2.
Could you write in good form?
Sorry. Hello.
Could you write this matrix in that form?
No. It's
change D.
No. Sorry, it's really long. I cannot, because I have explained it clearly for 3x3 case and the same procedure.
So it's same for that, sir. We only need to change. Sir, we only need to change the in place of D.
Yeah, that's all. In place
That's
of D,
sufficient.
you need to replace here minus A, minus B, minus C. Okay, that's.
Okay, sir. Okay.
Okay. I don't know, like.
Subhashish, there is this observation, the way you nicely explained the difference between rank of a matrix and rank of vector space of matrix, the difference, that rank of a matrix is of a specific matrix, whereas the rank of vectors is infinite types of matrices covering those standard conditions that have been stipulated. That maybe for future batches, if you can cover it as a tutorial, that would be helpful for future batches at least.
Okay,
because it was nicely explained, but in our existing tutorial plus the lectures, it is not covered. some people had actually struggled to understand that. And
Oh,
today,
okay, sure. I'll inform. Yeah, we'll try to make a video related to this. Yeah, sure. Yeah, thanks. Okay, any other doubt? Like I guess I have spent. So any specific doubt? See, the thing is, okay, like I guess we have covered almost all the concept of week 3.
So one determinant doubt.
Start with the basics of vector
So one
space.
more
It's like
doubt I'm
week-
having, I've already posted in the chat box that that column or row, how like vectors whenever we take and we arrange them for the row echelon form. Is there any specific rule that we should use in one vector? We should put it in the column form or we should put in the row form?
No. You don't have to follow any order. Like
Both will give the same result, right?
because that is the thing. Like this rank of that is basically because of this pattern. Rank of A is same as rank of
Right. Okay.
A
Okay.
transpose.
So both will give the same result, right? Okay.
It will give you the same.
Okay. Thank you, sir.
Yeah.
So are we talking about grade 4, week 4?
Someone asked me. Okay, let me go to the chat box. Okay, there are so many things in the chat box.
there is one more observation of this question that we solved 1 by PQ. What is the value? I think we did it some 2-3 samples back, just some time back. There is an alternate way of just doing it instead of going through decomposition into say basis vectors. Can we not do it that since the first vector is a part of that vector space, I just put it there and second vector also, then automatically P and Q value comes out?
Sorry. Can you repeat? Like I didn't get your question.
A few slides back, we have done one question. What is the value of 1 by PQ?
I guess in the
Yeah. This one. So here, if you can just slide up a little up, the question statement was, where was the question condition there? A little up. Where is that question? The question, yeah. So here, since it says in a span of P01, 0Q1 equal to V, and we have been asked to find out the value of P1 by PQ. So since we are talking about span of P01 and 0Q1, that means P01 is part of vector space V.
Yes, true.
If that is the case, then I'm sure that P01 satisfies the requirement of the condition that is given Z equal to 7x plus 7y.
Yes.
So then I can directly put it over there. P is equal to
Correct.
7.
So if you put P equal to, then basically what you will get? 1 equal to?
I will get 1 equal to 7P. Yeah. As well as in the Q also the similar way. 1 equal to 7Q.
True. Whatever you are saying is true. Yeah.
This is an easier way of doing the same thing rather than.
Yeah. I agree. This is much more easier way to solve this question.
Okay. Thanks.
So graded 4, question number 3.
So can you write down one statement, please?
No, graded for question number 3. I remember someone asked me. First,
so that's a small doubt. Okay, sir, I'll wait.
Okay, so Mohan Raj asked something. Can you explain some application question which can be solved by matrix? How to approach and application of real-time situation and solve these topics. Okay, so many people ask. So the main thing is one of the application. Okay, so as I said, like there is no direct, most likely there is no direct application of this basis and all these things. Okay, so the thing is there are, as far as I know, there are a lot of application of this eigenvalue and eigenvector. Okay, so this will help you to solve actually a lot of differential equations. Okay, so you can actually solve a lot of differential equation using this eigenvalue and eigenvector, and I guess for different, so there are huge amount of application, particularly in if you pick any area, then you will get some application of differential equation. So
okay.
Sir, will there be any mock tests for quiz?
Yeah, definitely. Like so actually I thought like we have already gave you the mock paper. Okay. So yeah, so basically I was wrong.
So will you be taking my question?
Yeah, yes, sure. Actually, I was checking the chat box, but yeah, it's like they have like many of you have written a lot of probably some other things. So it's now probably it's not difficult. It's not possible for me to check the chat. Yeah. So graded assignment question number.
Sir, 3.
3. Okay. Yeah. So it's. So you have a set. Okay, so it's basically asking you the dimension of the vector space. Okay.
Yes, sir.
So the operation is basically usual operation, right? Usual addition and scalar multiplication.
Yes, sir. Yes, sir.
Yeah. So this is my vector space. X, Y, Z in R, and you have two conditions: 0, Z equal to 0, right?
Yes, sir.
So Z is always 0, right? So I can write this as 0, and since Z is 0, I can write this as, right?
Yes, sir.
Now can you find the dimension of this vector space?
Okay. Okay, sir.
Clear, right?
One will be dependent and one will be independent.
Yeah, so dimension is
That
basically
will be
1.
Okay, sir.
Yeah.
Sir, same week, question number 8. Sir, hello.
Yeah.
Sir, I was doing, but I got 6. What is asking? How many following vectors will be in V? Sir, I found that all are in the spanning vector of these two vectors, but my answer get wrong. It is only 3.
Sir, for this question, I want to understand if calculating is the only way for all those 6 vectors, or if there is any
that is
smarter
the
way
only
to do
way.
it.
I don't see any other reason, other way to check this.
Okay.
So yeah, so basically, okay, so as I said, like many times, to solve this type of question is equivalent to solving a system of linear equation. If you know how to solve a system of linear equation, then basically you can solve this type of question. So basically, you want to know
coefficient of we take coefficient of -101.
You want to know whether this is in the span of this set, right?
Yes, sir.
So if this is in the span of this set, then you can write this as a linear combination of these two elements.
Yes, sir. I know that how to find.
No, if this system has a solution, so you will get a system, right?
Yes, sir.
So if the system has a solution, then this belongs to the span of this set. If the system don't have a solution, then this doesn't belong to the span of S. You have to check for all the elements.
Sir, if all if alpha comes out rational, then it doesn't depend.
Sorry?
It will not. Sir, if alpha, if I solve this,
alpha has to be a real number. That's all. It doesn't matter. It's a rational integer, negative integer, doesn't matter. If it is a real number, then I'm done. If I can find alpha, beta, which is in R, and it satisfies this equation, then I can say that 1, 1, 0 is in the span of this set.
Okay, sir. So somewhere I have done wrong.
Is there any way to use the determinant to find out whether these will have a unique solution or no solution, sir?
No, you can use the determinant, but the problem with the determinant is basically you can say that whether these three vectors are linearly dependent or independent. Okay.
Okay.
Someone asked that the graded assignment question number 8. Is there any other way to solve that? Can I tell any other way that
Yeah,
I
please.
solved?
Yes, please.
You can find the equation of that plane using those 2 points and origin, and then you can satisfy all the points in that plane. If those points are satisfying in that plane, those will be the correct answers.
Yeah, true.
Okay.
Yeah. This is another way. So the thing is, okay. So what basically he's suggesting, you first try to find out a equation of a plane.
Okay.
Which contains one. So how you'll find the equation of the plane? So this basically ax plus by. So if the equation passes through origin, then the equation of the plane should be in this form. Now you substitute the value of this here and the value of this here, you will get two system of linear equation, and from there you can actually get the equation of the plane. So now what you do, you try to put all the values in that equation, and you check one by one which of the following values actually satisfy this equation. So whoever satisfy the equation, they are actually in the span of this set is this set. And whoever don't satisfy the equation, they are not in the span of this set.
The two equations that we are getting by substituting these two vectors, we should subtract that, is it, to get the equation of the plane?
Yes.
Okay. Thanks.
And another way to find the equation of that plane is you can find the n vector, the normal vector for that plane, by using these two vectors, taking cross product of these two vectors, and then you take a general vector r vector, that is xi cap plus yj cap and zk cap, and take the dot product with this vector, the general vector r vector, with that the normal vector which you find for that plane.
Yeah, okay. I feel that is slightly complicated way to do it.
Okay. So actually it's a 12. It is in 12.
Yeah, that is basically you solve it in your class 12. Yeah.
Yes.
So you take something, you then compute the normal vector, and then you compute the equation of the plane.
Yes, sir.
Sir, I have a question, but I'm not sure if you're going in the chat order. If so, I will.
No, actually, I cannot follow the chat order because there are
Just one question. No need to solve it and all. There are a couple of questions which gave vectors in R2, and they were asking which of these form the spanning set, or which of these are linearly independent. So I'm not sure if putting them in a specific order in the matrix will change the result.
Sorry, can you tell me?
This is in AQ 4.1. I think question number 7. They are given 4 vectors in R2 space, like 3, 1, minus 3, 1, 1, 1, 1, 2, like that. And they are asked
question AQ 4.1, question number 7.
7, yeah.
Yes.
I tried solving it, but I tried solving it using the column vector, and I thought the column positions corresponding to the non-leading zeros, those vectors will be the linearly independent ones. That's what I thought, but I think that's not the case.
No, as I said, like how to check whether a set is a basis or not. You have two things you need to check, right? Basis, one is span and another is linearly independent.
Linearly independent.
So as you can see in the first one cannot be linearly independent, right? This set.
So are you writing something or showing something?
Yeah, I'm writing something. This set cannot be linearly independent, right? Because you have three vectors
in R2. Got it. Okay.
Right. So this cannot be linearly independent. So then the second one. So whether this set is a linearly independent set or not.
One second, sir. Yeah, take it. This is linearly independent, I think.
Because the determinant, you are using the determinant concept, right? If you form a matrix using these two vectors, so the determinant is non-zero, right?
Non-zero. Okay, so it has a unique solution.
So this is linearly independent, right? So from here actually you can say that the span of this set is R square, because the dimension is basically 2, and if you have a set which contains two linearly independent sets, that automatically will become a basis of that vector pair. But still you can actually prove that the span of this set is R square. So how you will prove that? Okay. You pick a element in R square.
Okay.
You need to show that you can write this element. You can write this element as a linear combination of these two elements. That is basically you have to show that minus a plus b 3b equal to x, 2a plus b equal to y has a solution for all right?
Okay.
So if you can show this one, then basically you are done, right?
Okay.
The span of similarly you have to do the same thing for option 3, I guess. Yeah.
Okay.
Again, I guess that that is also a basis of R.
Okay. Actually, the way I tried to do it was I tried to form these 4 vectors as column in a, I think.
No, AS is not a basis. AS is not a basis, certainly, because you have lot of vectors in AS. You have 4 vectors, so it cannot be a basis. It cannot be linearly independent. Okay, so in the option we have not asked you anything about the set S. We have asked about the subset of this.
Okay.
So can we say that?
So what I tried to do was to find out the basis of yes. Okay.
Yeah. So basically, in this question, you have to solve option by option. You have to first.
Got it. Thank you.
You cannot conclude anything from S. Like you have to basically you have to solve the each option individually. Okay.
Thank you.
So can we say that for Rn, n is the number of bases?
N is the cardinality of a basis. Yeah.
Yeah. We can directly neglect the first option by that.
Yeah, that is what I said, right? This cannot be a basis because it's not a linearly independent set. Yeah.
Okay. So can I ask my doubt now?
Yeah, please.
So please write A is equal to Square brackets C1, C2, C3.
C1,
C1, C2.
C2.
No, in the horizontal way. C1, C2, C3. And A4 is equal to C1 plus C2.
Okay, that's all.
Yeah, that's all. Now another matrix A1 is equal to first element is C1 plus C2. Second element is C2 plus C3.
Row or column?
Horizontal only.
Second is
C2 plus C3.
And
third element is C3 plus C1. So please derive the relation between A and A1. Sir, I am not able to solve that.
What do you mean by the relation?
So these are the C1 is the column C1 represent the ith column of a matrix A.
Yes, C1 represent the ith column of the matrix A.
Yeah. Yes, sir. So, sir, I want to find the relation between A and A1. A determinant of A and determinant of A1. Sorry.
Yes. So that is, you should ask like the determinant of.
Sorry.
Yeah, relation. Yeah. So it has no meaning. No. So I guess it's maybe from one of the activity.
Yes, sir.
So yeah. So the thing is determinant of A and I guess determinant of B can, if A1 can be different, they are not same.
Correct, sir.
I guess I have actually explained it one of the session. So if you take this matrix, A to be this matrix, then what will be this matrix? This you will get 1, 1, 0, right?
So the relation between these are determinant of A1 is equal to 2 times determinant of A. So the option was, this was the option. Correct option.
Okay, then.
Yes, sir.
Okay, so let me derive that one. So just a minute. C1 plus C2 plus C2 plus C3, C3 plus C1, right? Now,
correct, sir.
I'll convert this to some matrix, say A dash. So what I'll do, I'll subtract this one with this one, means the column 1 of this matrix with the column 2 of this matrix with the column 1 of this matrix, right? So what I will get, C1 plus C2, then what I'll get here, C2 minus C1, then C3 plus C1, right? Correct?
So what are we doing in the column 3?
No, I'm subtracting this column, column 2 of this matrix with the column 3 of this matrix.
Okay.
So this is a new matrix, right? Some maybe say A4 dash.
Yes.
So do you agree that determinant of A4 dash is same as determinant of A4?
Yes, sir.
That is one of the property, right?
Yes.
So next what you do, you add this row with this row. Sorry, this column with this column. What you will get?
2C2.
2C1 plus C2, then 2C2.
Yes.
Then
C3 plus C1.
C3 plus C1. Then what you do? You subtract this one with this one. What you will get?
C3 minus C2.
C1 plus C2.
2C2.
2C2.
C3 minus C2.
C3 minus C2. Right?
Right.
So determinant of all these matrices, they are basically same, right?
Yes.
So now can you tell me what will be the relation between determinant of this matrix and determinant of this matrix?
Two times.
Yeah, basically determinant of this matrix. Basically 2 times determinant of this matrix, whatever matrix you have. C1, C2.
All right.
C3.
Okay, sir. Thank you.
Yeah. Okay, so any other doubt?
How are we getting the last one? If you can just know, the last line I could not follow.
Which one? This one?
Yeah, the last one is equal to 2 determinant of C1, C2, C3.
Yeah, so basically, see what basically you will get. So you have C1, C2, C3, right? So determinant of this. So do you agree determinant of this is same as 2 times determinant of C1 plus C2, C2, C3 minus C2? Do you agree with this fact?
Yeah.
Yeah. So then C1, so you have C1 plus C2 plus C1, C2, C3, right? So determinant of this matrix is same as C1 plus C2, right? C2, C3, right? The determinant of this matrix is same as determinant of this matrix, right? Now determinant of this matrix.
Now it's clear. Yeah.
Yeah.
Second one added to first one, then second one subtracted.
Yeah,
third one.
true. Then determinant of this one is basically same as C1 plus C2, C2,
Yeah, C2 and C3 minus
C3
C2.
minus C2.
Okay. Basically, we have to just follow row deduction or column deduction method.
True. Yeah.
Okay, that's what.
So how? Sorry, how does this? Sorry, this step C1 plus C2, C2 and C3. This one, how did it come?
Which one? This one or which one?
No, the previous one.
This one. No, I have added the column 1 with column 2 of this matrix.
Column 1
with column 2.
Sir, better we can
column 3 you change C3 minus C2 became C3. How did that become?
Actually, this is A matrix.
Parent matrix of this is C1, C2, C3.
No, C3 minus C2 became C3, right? Third column.
This one.
No, that is come from C1, C2, C3 and an arrow is given. And in this C1 plus C2, C2 and C3. The main thing is where has added in the first row to the second. Sorry, column.
Okay.
Sir, I have a doubt. Graded week 4 question 5.
Yeah. So which part of so you have some bunch of statements. So what is your doubt in here? Okay, sorry, I'm checking activity question. Yeah, sorry.
No, sir, graded week 4 and question 5.
Dimension of the space, right? Hello?
Yes, sir. Yes.
Like as I said, I have explained all this question like in the session maybe a lot of times. You just have to replace.
Sir, actually, where we can say 10x1 is equals to minus 10x5.
Sorry.
Okay. And numericals value is changed only, sir.
Yeah, so basically it's maybe some like for different people.
No problem, sir. No problem.
So you need to find the dimension, right?
Yes, sir.
So from here, you can get a relation between x1 and x5, right?
Yes, sir. Yes, sir.
Suppose then x1 is basically what?
X1 is basically minus 4x5, 4 by 7. Yes, sir. And same is x2.
X2 is minus 9 by 4.
Yes, sir.
X4, right? So so a arbitrary element of this space should be in this form, right? Minus 4 by 7.
Not 9 by 7.
True.
Okay. No problem.
Yeah. Sorry. Yeah. It should be minus 9 by 7. So this is minus 4 by 7 x5, and instead of x2, I can write x4, right? Then I don't have any other relation. I don't have any relation of x3 with some different variables. So I'll write it x3, and I have x4, x5, right? So this should be a general element of this vector space W, right?
Yes,
so now can you see what will be the dimension of this space?
Yes, sir.
It's basically 3, right?
Yes, sir.
Because as you can see, you can write this is x5 0 0 0 x5, right? Then you have minus 7 by 4 x4. Sorry, made a mistake. This would be 0 minus 7 by
minus 9 by 7
4 0 x4. This is 0, right?
Yes, sir.
Then you have 0 0 x3
x3.
0. So then you can, from here you can say that the basis is basically what? Minus 4 by 7 0 0 0 1, then 0 minus 9 by 7 0 1 0
1 0
0 0 1 0. This is a basis of top.
Yes, sir, I got.
Got it, sir.
Yeah.
And sir, the level of quiz will be same as of video assignment questions only.
I guess it will be question will be even easier than some of the questions.
Can you scroll up for this question?
Now relieved.
Can you scroll up for yes, sir?
Yeah.
So this is so I just missed I lost connection for a couple of minutes. So can you just let me know what we have done it here, sir?
No, we have tried to compute the dimension of this space. Right? So
okay, so this is the operation. Is it? These two are
so
operations.
the two conditions were given.
Okay.
So from here we got x1 in. We can write x1 in terms of x5
Yes,
and
sir.
x2 in terms of x4. So we
Yes,
just
sir.
replace the value of x1 and x2 over here.
Okay, sir.
So then the usual process, we have tried to separate x1. Sorry, we have we tried to separate x5, x3, and x4. Okay. So
selectivity
5 0 0 0 x5. Okay. 0 x4.
Okay.
Can you
Since,
Activity
one second,
two.
sir, just 1 second, sir.
You can see the recorded lecture, I guess.
Just hold on for a minute, please.
Sir, may I ask?
So how x5 is not x5 is factored in with the first one. So
I'm taking x5 out common from here, x4 common from here, and x3 common from here. That will give me the basis. Okay, so next question.
Okay, fine. Thank you.
Yeah.
Sir, may I ask? Sir, I have to ask week 3 graded assignment question. Question number 7, sir.
Have you checked the solution?
Sir, I am not understanding. Sir,
No,
I
my question is, have you
under-
checked the solution?
Yes, sir.
Okay.
Sir, I understand the question. Okay, what question is saying, but I'm unable to make matrix in the form of AX is equal to.
No, the matrix is given, right?
Yes, sir. Yes, sir. P is given.
Yeah. So
Now,
then why you need to form a matrix?
sir, now when in question number 7 say find the set of correct options from the following. So, sir, we have to check for x1 and x2. Then we have follow this relation xn minus 1p equal to xn, right? Sir, after that, sir, please discuss a little, sir. Maybe.
Sorry.
Sir, discuss a little bit. It will help me to understand the question.
This question itself is too long.
Sir, in this question, the vector x0 is given as 1 by 3, 1 by 3, 1 by 3. The description does not match this. So it means they are assuming 1 by 3, 1 by 3, 1 by 3, because x0 will not be 1 by 3, 1 by 3.
That is the initial.
Initially, it will
which
not
one?
be, because in the description, the pattern is only RR, RR, and RR. So you will not have a possibility of small r at all initially.
1, 1, half, 0, half, half, 0, 0. Yeah, you don't have possibility of
So, but the vector x0 gives 1 by 3, 1 by 3, 1 by 3. But why such a thing? Are we?
No, which one? 1 by 3, 1.
X0. Ninth question, they say x0 is 1 by 3, 1 by 3, 1 by 3. But it should never be 1 by 3, 1 by 3, 1 by 3.
Why
right?
x0 can be anything, right?
No, because we are assuming that RR is 0, right? For this combination, we are starting with this set. We are starting with this kind of parents, right? So in that case, the first generation, there will be no small r, right?
These are the probability of offsprings. Consider the crossing of RR with RR. This always give a genotypes.
Sir, your screen is frozen, I think, so I'm not able to see it.
No, I'm not actually. I have not opened. I have opened that question in a different system. Yeah. So the thing is, okay. Then each and every time I have to stop sharing my screen. That is the problem. No, x naught is basically the initial distribution vector, which is denoted by x0 vector, that x naught. So it can, yeah. So initial distribution can be anything, right?
Initial distribution. E2, because RR x3 determines the RR offspring, right? Small RR offspring.
No, so that is, they are saying like the offspring probability of an offspring to be this RR and RR is that this R and this R is 0, right? This is 0, this is 0, but this is the probability, but the initial, we can assign some initial number, right? That is not a problem. Initial thing can be anything. Like after that, maybe there cannot be offspring. The probability can be after that. The probability of an offspring of this and this is 0. That is I agree. But the initial distribution can be anything, right?
No, sir, because this will determine after how many generation it will be completely dominant, right?
Yeah, so this will determine the next generation, right?
So, but when
But
we
the
are
initial generation, certainly it's not going to determine, right?
because
So initial we have assumed some vector.
I see. Hmm. Because initially itself, I don't see the third part being 1/3 at all. It should be 0. It should be, other two should be equal and the third one is. So that is how it will start.
Yeah.
X0 will start. Then thereafter, X1, X2 will become immediately 1. The first one will become 1. 100 will become in 2 generation itself. But when we are 1/3, 1/3, 1/3, it goes up to 3 generations.
Yeah.
So I was wondering, why is the question like this?
Okay. Okay, like
can I can I ask my question, sir?
Yes.
Sorry. Yeah, activity question 3.1. 10th question, which statement is correct here?
Question number 10.
Yes.
Yeah.
So which statement is correct here?
The statement 1 is incorrect.
Statement S.
Sorry, statement P is incorrect. Statement Q is incorrect. Statement R is incorrect. No, sorry. Statement consider illustration x equal to t, where A is invertible matrix, A is x1, x2, and B is non-zero. Okay, so statement R is incorrect.
Because B is non-zero?
B is non-zero, yeah. So, so certainly in that space you cannot have 0, right? In W. Statement S is correct.
So for W space, we need to have B equal to 0.
In to be a vector subspace, you need 0 vector, right?
Yes, sir.
So in that space, you cannot have 0 vector because B is non-zero, right? You multiply it. So yeah, only statement S is correct.
Can you please share a screen?
For what?
For this question, I am not looking that what you talking about.
No, like that is what I am saying. Like the activity 3.1, question number 10.
The statement Q is because determinant of A plus B is not equal to determinant of B, right?
Yeah. As you can see, this is not closed under addition.
Yes.
So explain please the statement P and Q. So just brief review how they are incorrect.
Yes. So basically both P and the set W for statement P. So this is my statement P. So it's W is basically what?
A square, all A matrix, 2 by 2 matrix where A square is equal to A.
This set is not closed under addition. Addition. You basically you can find 2 matrix where square is itself, but the sum of the square is actually, so you can find 2 matrices A, B, so that A square is A and B square is B, but A plus B whole square is not equal to sorry, not equal to A plus B. It's not difficult. You need to pick some matrices. You will get it. Okay. So that's why it's not a subspace. Same with the statement Q.
Determinant A is equal to 0.
Determinant of A can be 0. Determinant of A is 0. Determinant of
B is 0.
But
A not 0.
Determinant of A plus B is not 0. So it's not closed under addition.
Okay, sir. Thank you.
Yeah, thanks.
Sir, last question, and then it will be over. So activity question 2.2, third question.
2.2, third question.
Sir, I got values of a determinant equal to 3, a x1 equal to
Question
minus.
number activity 2.2, question number 3, right?
Yes, sir. Sir, I got a determinant equal to 3, a x1 determinant equal to minus 2, a x2 equal to 2, and a x3 equal to 3. So considering the options, so here x2 is given minus 2. So but sorry, x1 is given minus 2 in the option. That is the correct option. So but according to me, x1 should be ax1 divided by ax1 divided by a1. Sorry, a determinant.
Ax1 determinant of ax1
divide by a determinant.
Determinant of A.
Yeah, that will give me the x1.
The coordinate of x. Yeah, this x1. Similarly,
Yes,
x2 and x3. Yeah.
Yes, sir. So here, if I divide for me, determinant of ax1 is minus 2 and determinant of a is 3. It will give me minus 2 by 3. But the answer is minus 2.
Okay, okay, it's basically it's computation. Have you checked? So what is the determinant of ax? So what is the determinant of a first of all?
Determinant of a is 3.
Determinant of a is 3.
Yes.
So you're sure the determinant of a is 3?
Sir, if you say I'll check it computationally, but are you sure it is the computational error only, like nowhere else?
No. If see, the thing is, okay, I'll check. If either you have done some mistake or otherwise we have done some calculation mistake. Okay, so certainly x1 is this. Okay.
Yes, sir.
So that is the case. So you just need to compute this one, and you just need to compute this one.
Yes,
okay.
Sir, because in both the options, it is x1 equal to minus 2 and
so what is ax1? Ax1. So what is ax3?
ax3 is 3.
What is ax3? The matrix I'm talking about, the matrix.
Okay.
So this is the matrix, right? Your ax3 is 1, minus
0,
1, 0,
yeah.
0, 1, minus 1, and
1,
1.
Yes.
Yeah. So you just compute the determinant. Okay, let me compute it. So
Sir, I'm getting 3.
Determinant of A is 1.
Determinant of A is 1.
Yes.
Okay. Maybe I have got computational error in that then.
Yeah. Okay.
Okay.
Okay, fine.
Thank you so much. Thank you.
Okay, any other doubt, or shall I stop the session?
I have a doubt. That is in week 4, activity 1.
Week 4, activity 1, question number?
Not 1, it's activity 2, AQ 4.2. I have a doubt in question number. Just a second, sir. Actually, I just mentioned on the chat. Just a second.
Okay, please, yeah. Hello, am I audible?
Yeah, yes.
Sir, it is in activity 4.1.
4.1.
Yes, sir.
4.1.
Question number 2 and question number 5. AQ 4.1, question number 2 and 5.
2 and 5.
Yes, sir.
So what is your problem in question number 2? What actually you are having problem in question number 2?
So I just wanted to know which all statements are being correct and which all are incorrect.
Okay, so statement
What is
1.
the reason?
So the first statement is span of S is basically this consists of only lower triangular matrix, which is wrong. Okay. The statement, I'm talking about question number 2, statement P. Then the statement Q is span of S is vector consistent only upper triangular matrix of order 2, which is true. Okay. The span of S is the vector space consisting of all the square matrices of order 2, which is incorrect. The span of S is the vector space consisting of only scalar matrix of order 2, which is also incorrect. So only one statement is correct here. This basically the span of this set is
So
upper.
how you are checking it out?
Yeah, so this is the, so this is the set, right? So the span is basically what? This set. So this is basically span.
Yes, sir.
So so if you add basically what you are getting. So basically you are getting all the upper triangular matrices, right?
Yes, sir.
Yeah, so that's why. And similarly, this is basically the same thing. Yeah, so you just need to compute.
Just now I can see 5 questions by my own.
Yeah, it's basically the diagonal matrices. Yeah. Okay, so then I will stop this session. Yeah. Okay, thanks.
Thank you.
Yeah.
Thank you, sir.
Thanks.
Thank you.
Thank you, sir.
Yeah, thanks too.
Thank you, sir. சொல்லுமா நான் இங்க பின்னாடி இருக்கேன் ஓகே சொல்லுங்க அவர்கிட்ட போய் சொல்லுமா சொல்லு